Hello, my dear students. Welcome back to the lecture. So from here onwards, we'll try to carry out the steel estimation, which we call it as a bar bending schedule, which is called as BBS, which is called as, I'll write it here. If you don't know, it's called as bar bending schedule. Okay, or schedule, one and the same. It's called as BBS. Okay, fine. So again, for that, we have the format. We need to understand the format. Like for quantity estimation, we had done the format, right? In the same way, I'll teach you how Excel sheet has to be done and we'll follow the same thing. Yeah. So how do you prepare such things? You know already, but still, let us start it from the scratch. Okay, done. So what I can do, I'll just go here. I'll write project. Okay, it will take some time because some may understand, some may not understand. So I'll do everything in front of you. Project, client. Okay, like you did previously, the same thing. And then you also prepare the Excel sheet. Anyhow, you need to prepare. I won't be sharing any of the Excel sheet. Consultant. Okay. And then last is a type of structure. So type of structure or type of element is good. Type of element you do instead of structure, right? Element. Okay. So structure doesn't make any sense, right? Type of elements. So elements can be a footing, column, all those things. Okay. Fine. So that means it's done. So here also I'll make it as type of element. Like if it is footing, whatever it may be. Element. Yeah. Fine. After that, I'll copy the same thing. You have to write. I'll tell you what has to be written. It will be a time consuming for me. So, okay. So what I've done, I've written the project is G plus 2 story residential project. Client was Nayak Bungalow at Bangalore. Consultant is Kamath Construction. Type of element is footing. Okay. I'll take out the color for timing. Later we can give the color and all. Okay. And also the border not required. No borders. Yeah. Done up to here. After that, I want to write this drawing number BBS revision. Okay. There in estimation also you could have done the same thing, drawing number, and you could have written uh, revision also, but not required. Here we'll do that. You can take anything from here. I'll do somewhere here. I'll write BBS revision. Okay. Revision in the sense sometimes your drawing keeps on changing. In that case, your BBS also will change, isn't it? So BBS revision I'll write, and over that I can write drawing number. Okay. So drawing number, like here in the AutoCAD, I've shown you one drawing, but when you release the drawing, each of this will be a separate drawing. Let us say your architectural plan is drawing number 1. This will be your drawing number 2. That is your footing foundation layout. Then after that, your column will be drawing number 3. Okay. So that is why in AutoCAD you see separately we have done all these things. Then this will be your drawing number 4, maybe the staircase detailing part. Then ground floor layout will be drawing number 5 and so on. Okay. And that is the reason I've written it here. Drawing number and BBS revision. After that, what we have? Yeah, grade of concrete, grade of steel, lap length, development length is very important for us in BBS. So I'll write it somewhere here. Okay, I'll write grade of concrete. Okay. Then I require grade of steel. Okay. Grade of. So I hope the basic BBS part you people are knowing, because if you've taken a lot of my courses like construction methodology and all, there I've explained you all these things. And then comes the development length. Okay. Development length. I'll explain you all these things in the later part whenever we need to understand it. Okay. Yeah. But anyhow, in the basic part, I've explained everything. So grade of concrete, I think in most of the cases we have taken M20 only. I'll go with M20. So grade of steel, usually in the RCC, minimum we go with FE 500. So I'm considering FE 500 here. Okay. Lap length and development length, we can take it from the structural drawing later. The last part is the concrete cover, rebar length, total steel quantity in footing. Okay, what is that? Concrete cover. I can write it somewhere here, right? Concrete cover, then concrete spelling. Then rebar length, and then total. Yeah, total steel. Or you can write rebar also. Total rebar in footing. Okay. So total rebar in footing. or rebar quantity in footing, one and the same. You can write your total rebar quantity. Okay, done. Everything we have done. Now we need to make it beautiful. So how do you make it beautiful? Just select everything. First, we'll give them a good font. So I usually go with this. You can take anything also. Anything else. Okay, this also looks good. This also looks good. This also looks good. Okay, I'll go with this. Fine. So one thing we have decorated. Second thing, what decoration we can do is I'll select everything. I'll go with a bold one. We can make it bold. Okay, that's the second. Then you come here and give all borders. What you have to do? Select everything, go for all borders. So everywhere the border will come. Now, wherever it's not required, we'll merge it. For example, here I haven't written anything, no? So what I can do, I'll just take down this part. Okay, this part is anything not anyhow not required. I'll select everything in the bottom. I'll say merge at center. So it becomes a plane now. So this much part is of no use to us. This much part, again merge at center. Okay. Then again, this anyhow you are going to write revision number and this you will be writing. So we'll make it as one single unit. Okay. Merge at center. So one mistake what we did is, okay, not a mistake. It's okay. Again, you just drag it so that it looks good. Yeah. So concrete cover M20. Okay. Fine. If you want, you can, merge this and say merge at center so that it will come in one single line. Even for the lap length and development length, you select it, merge at center. Okay. Then again, this part is not required. Just merge at center. Okay. I think most of the things we have made it look good now. So development length, this quantity is not required. Make it merge it. Okay. Done. So once these things are done, everything looks good. Not an issue. See, grade of concrete looks good. Grade of steel, lap length will be writing here. Development length. This also you merge it. Yeah. One thing I think this we made a mistake here. No. See, total rebar quantity. What I can do is I'll not merge it. See, when once you have merged it, if you want to get it back, just select on that and go back to this. Okay, go back to this. Okay, I think merge center. Yeah. Okay, I think then how do you get it back? I think I need to put the this thing again, and then I think wait. I'll just take it out. I'll say Control X, so it will cut everything not required. Let me write it here. Control V, and this part is only up to here. Okay, I'll say all border. Okay, and let me write it here. Total rebar quantity in footing. Control C, and I'll write it here. Control V. Okay, then I can just say merge at center. Yeah, now it looks good. And now see, now it's not looking good. It's not visible. We know what is the this thing. Okay, this also you do all border. Not coming. It should come all border. So if it's not coming, you have to unmerge it. Go to this option. Yeah. Now you select this much part. Select this also. Now you merge at center. And then there's one option called as wrap text. Click on that. Done. Okay. Now it looks good, no? Yeah. So you do one more thing also. You just select this part. Put them in a single line. Let it come in one single line. Yeah. Now this is okay. This will be a concrete cover part. This will be a rebar length. And this you break it and merge it. If this much is not enough, what you can do, no? You can take this part also. Take this, and take this part. Fine. Okay. This will be one. This will be another. Then this guys make it another. Okay. Done. It looks good now. So just minimize your screen. Now everything looks fine. So now what you can do, you just have to, yeah. If you want, you come here, give a thick box in this way so that it looks good. That's it. Okay. Yeah. This you merge at center. This also you merge at center. Done. Yeah. Here one thing you require. Here one proper listing is required. This you do. And then this part you say all borders. Yeah. Now it looks good. Okay. Everything is done. This is not required. Just delete this part. And how to delete this? You have to go back and say no borders. No border, the border part will go. Okay, done. I think everything looks good. Now, if you want, give a color to this. That's it. So color, I'll go with the yellow color, or even you can go with the green color. Whatever color you want, you go with that. Yellow looks good, so you can go with the yellow color. Okay, done. So this part, yeah, merge at center. Fine. I'll just minimize a bit so that everything comes in one line. Okay. So once this is done, next what you're supposed to do? Next is I need to do this one. That is serial number, shape of bar, bar description and all. So we'll write it. Since you have to write it, I'll also write it. Okay. Write serial number. So SL number, SL. Okay. Serial number. Don't give the color, say no fill. Later we can fill that. Okay. After serial number, it is shape of bar. So write shape of bar. Okay. After that, we have bar description. So after that, yeah, we'll write bar description here only. Bar description. Okay. After that, all these things are there. I'll copy it. Okay. I'll copy it. Or anyhow, I'll write number of member, because I don't know what all challenges you may face there. Next is dia of bar. I'll write all these things, no? So again, I'll write dia of bar. So in that case, what will happen? It will come out. Then what you're supposed to do, go here, wrap text. That's it. Else, what you can do? Else, what you can do? You just have to drag it and you have to merge it. This thing. Merge at center. Now bring it to the second portion and make it dark. That's it. Okay. Dia of bar. Okay. So it is in mm. So write it in mm and close the bracket. Okay. Again, then go for wrap text. It will come good. It will look in this way. Yeah. In the same way, spacing, again, write mm. So again, you merge it in this way. First you, okay. So write spacing here. This also, this, everything. So merge at center. Okay. Now it looks good. Now you write all those things. Spacing. Okay. So spacing, that will be in mm no again. Close the bracket. Done. So it doesn't look good. No, go for the wrap text. And then you make it bold. So, and then you bring it at the center. So what you can do, you can apply this everywhere and do it. Like what I'm trying to tell is select this, say come to this point, say wrap text, say bold. Now you don't have to face any problem. Directly it will take care of it. Next is number of bars. Number of bars. Okay, see everything it has taken care of. After that, cutting length. Cutting length. So cutting length, it should be in which one? First it will be in mm. Later we'll convert that to meter. So cutting length in mm. Next is again you copy this Control C and you Control V it, but here you make it as meter. That's it, and close the bracket. Done. So then cutting length. Next is total cutting length, which will come in meter. Again we have these options. Select them. Okay. So merge at center. Go to this point, wrap text, and say total cutting length. Who in meter? Not okay. Meter. Close the bracket. Enter. So again you make it bold. Done. So meter is not shown. It should, okay. Wrap text. Okay. No problem. Now it should come. Okay. Yeah. See, otherwise you can increase the size also. No, doesn't matter. Okay. It's not that it should come. See, in this way it will look good. Depends on you how you want to do it. Okay. Fine. Now the last part is very important. This is about the steel part. For 8 mm, what is the weight? All these things you know. How do you find that? I'll tell you later. How did this value 0.395 and all will come? But till that, you just concentrate on the other part. So you write here 8 mm bar. Okay. Then you write 10 mm bar. We have 12 mm bar. We have 16. We have 20. We have 25. We have 30. 32. Because in our building, 25 is the maximum bar what we have. So we'll go up to 32. Not an issue. Beneath that, you have to write the weight. So weight, uh, just copy from here. I'll tell you how it has come later. Okay. 0.395. 0.395. 395. And after that, it is 0.617. 0.617. After that, it is 0.888, 0.888. After that, it is 1.58. See, one thing you remember, according to IS code book, okay, according to IS code book, from 8 to 12, here 8 to 12, after the decimal point, only 3 digits you have to take: 395, 617, 0.888. From 16 diameter onwards, after the decimal point, you have to take only 2. It's written in the code book, that is in BBS code book. So that is why I'm following that. Okay. Yeah. 2.47, 3.85. And the last one is how much? 6.31. 6.31. Got it, no? So this I'll combine in this way. In this way, I'll select everything. What you're supposed to select in this way, merge at center and write total weight. So it is total weight of your bar. Okay. So what is that? What did I write there? Yeah, total weight. So make it in capital, total weight. And now you should say it is in kg. Okay, kg. And close the bracket. Done. Everything we have done now. The only thing is, again, you have to decorate. That's it. Got it? So now we'll decorate it. So how the decoration should happen? This you can make in 2 layers. Okay. Up to here we had not done, no? You can make it in 2 layers. Because up to here the 2 layers happened. So you just drag it up to this point. Okay. Got it, no? This should be in this way. And say merge at center. Not coming? No problem. So take 3. Say merge at center. Take 3. Say merge at center. Take 3. Say merge at center. Okay. Done. Now you select them. Then you give a good okay, selected, come here. Okay, we'll keep this one only. Okay, and then you select everything is bold, and then you bring them at the center. You, if you want to, yeah, align them at the center, and then go for all borders. Done. Now if you want, just adjust them. That's it. Number of members. Okay, as far as possible, try to bring it in one single. Like when I try to see my Excel sheet, it should, everything should fall in one place. Okay, I think everything is good. So now if you want to differentiate something like this weight and all, just give a different color to that, so that yeah, now it looks good. So it's understood that these are the different weight. Other than that, most of the part looks good. This, if you want, you can color it with a different color. This looks good. And this entire thing, this also you make blue only. Okay, then these are the part under that. Then if you want, you can give one this thing, select them, say one thick outside box, so it will look little good. Okay, that's it. It's enough. So once this is done, next we have to go with the shape of the bar description part, and all these things. So in the next lecture, I'll teach you how the bar bending schedule should be done. You know already, but I'll take one simple example, I explain it. And for the entire building, I'll teach you how it has to be done. Which is that building? This is a building. Okay, I'll go with this building now. For interior part, I had taken the other building so that it was easy for me. Otherwise, it was a G+2 building. My lectures would have gone for even more it would have been more time consuming. But since we did our estimation for the this thing, which is that superstructure for this, so I have everything here: F1, F2, F3 footing. For this, I'll show you how this BBS has to be done. Okay, so in the next lecture, try to prepare this so that it looks good. In the next lecture, we'll try to take care of all those things, and we'll prepare Excel sheets. We'll see you back in the next lecture. So once we have arranged all this Excel sheet, up to here we have done, right? After that, we are supposed to make an Excel sheet something like this. I'm going to teach you all these things step by step, how it has to be done. So before that, quickly, I'll explain you how the BBS has to be done for one footing. And once we understand that, only then we can prepare a Excel sheet, right? So that is the reason I'll take you to one of the BBS, which I've done it manually. If you know, it's well and good. If for someone who doesn't know that, I'll quickly give a recap of this, right? Yeah. So imagine I have a footing, okay? And the size of the footing is 2050 by 1850. This is my length and this is my breadth. And the depth of my footing is 400 mm. And this is a reinforcement what is given. That is along the shorter span, I'm supposed to provide a 12 diameter bar at 185 center to center spacing. And along the longer span, I need to provide a 12 diameter bar at 205 center to center spacing. So when I say center to center spacing, this is what it means. Okay. So that, for example, if this is my shorter side, I'll quickly give you an idea. This is my longer side, okay? And this is my shorter side. So in the longer side, if I say center to center spacing, this is the center to center spacing along the longer side, okay? And when I say center to center spacing along the shorter span, so this is my shorter span, right? Isn't it? This is, I mean, yeah, I think I told other way around. Wait, yeah. So if it is longer span, then this is how it is, okay? This is the center to center distance between the longer span, because this is the length what I have. This is the length what I have. Then I need to consider this as a longer span. So when it says center to center spacing, this is that spacing what we have. Okay, great. Okay, right. Now, when I come to the shorter span, so this is the center to center spacing what I have. So this is my center to center spacing. Okay. So which diameter of a bar you are supposed to use? What should be the spacing? Those things it will be mentioned in the drawing. Okay. Same thing I'm going to teach you later once we start with the project for this. But to give you an idea, I'll show you once again here. So just concentrate here. If you see here, this is F1 footing. The length and breadth is given. The depth is also given. L1 in the bottom reinforcement. L in the sense along the longer span, you're supposed to provide a 10 diameter bar at 150 center to center spacing. Okay. To put it in a better way, I can do it in this way. Yeah. See, this looks good now. So this is what it is. Okay. Let us consider this is my length and this is my breadth. So along the length, what you're supposed to provide a 10 diameter bar at 150 center to center spacing. So all this reinforcement, whatever you have provided, no, longer span, this is 150, 150, 150, 150, 150. In this way, all the bars are placed around 150. In the same way, B1 is along the breadth. So this is my breadth, or let us say a shorter span. Okay. There also you are supposed to provide a 10 diameter bar and the spacing is 150. That means again, this spacing also, it is 150 here. This spacing along the shorter span, this spacing, whatever you can see, isn't it? This is also 150. So this is a practical application of that. And with the help of this drawing, we'll try to check how many bar you are supposed to provide, like 1, 2, 3, 4, 5. You can see, no, a lot of bars are there. We need to find how many bars will come along the longer span, how many bars will come along the shorter span, and what will be the total weight of steel that is required. So that is why the bar bending schedule has to be done. So I hope you have got an idea. And now the same thing I've written it here. So again, you see here, this is my longer span and this is my shorter span. So first we'll start with the shorter span. In the shorter span, I'll try to find what is the cutting length of my bar. Okay. So cutting length of the straight portion along the shorter span. So how do you find the cutting length? Whenever you find the cutting length along the shorter span, what we do, what is the length of your shorter span? It is 1850. You should not take the complete length. You need to take out the cover. You have to take out a 50 mm cover from this side and you need to take out 50 mm cover on the other side, right? So if you're not understood, just check here. See, this is a bar what we have provided, isn't it? So this is a bar what I have provided. See, this is a bar what I have provided. And a small L shape you can see here. Small L shape we are given here. So this is 1850 actually. Practically, this outer to this outer is 1850. I'll write it here. This is 1850 for me. Okay, great. But whenever you put the bar, no, you don't put it completely from this end to this end. We give a cover. You can see this is called as cover block. If you've taken my basic course, you know that. So this is called as cover block. So for the footing, I'm going to leave 50 mm from the left side, 50 mm from the right side. So out of 1850, if I take out or if I deduct 50 out, 50 from the left side and 50 from the right side, what is left out? 1850 minus 50 will be 1750. So this length, whatever I'm going to get, no, this length from here to here, it will be 1750. You're getting my point. So this is how you're supposed to calculate it. Okay, great. So having said that, I've done the same thing here. So just check here, 1850 minus 50 on the left side, minus 50 on the right side. So which comes out to be 1750. Now you may ask me one question. So why it is 50 mm? See, there are certain rules or there are certain standards which we need to follow. For the footing, we take cover as 50 mm. That is why I had taken. Now, is it that every time it will be 50 mm? Most of the cases it is 50 mm. There are certain cases in case of raft foundation where you are supposed to take this as 75 mm. So all these things depends on the project specific. But 90% of the cases, if it is a normal isolated footing and all, usually 50 mm is what we take. But sometimes it will be written in a structural drawing what kind of cover you are supposed to take. if it is mentioned, if it is a rough foundation and you are supposed to take out 75, in that case, instead of 50, we'll deduct 75 here on both the side. Getting my point? But here, since it's an isolated footing, what we have, I'm going with 50 mm. Got it? Coming to the column and all, I'll take it in a column section, not here. Okay. Now we found only this length, isn't it? Agree with me? Only this length I have found. What about this length, and this length? What, how much we are supposed to take, right? So that also we need to find. Like this length we are supposed to take, no? If I show it here, this length, this L shape, you can see this bend and this bend. That we didn't calculate because we calculated only the bottom straight portion. So what will be this and this height? So for that, again, what you need to do, will come here. Usually this depth will be given, right? What is the depth of your foundation? It is 400 mm. So what we try to do, we usually deduct the top and the bottom cover. What we do, whatever is the depth of my footing, like if this is my depth of my footing, okay, see this length I want, no, this is my depth of footing. So it is mentioned 400 mm. The depth of footing is 400 mm. So what we try to do in this 400, we'll take out the top cover and we'll deduct the bottom cover. You can see in this bottom, you can see, no, it is 50 mm. This height is 50 mm. Okay. So from the bottom 50 mm we'll deduct, and from the top 50 mm we are going to deduct. Okay. So 400 minus 50 is 300 mm. So what we have done here, I've written 300 mm. See, development length is 300 mm. Okay, that is one way of doing. In some of the cases, what people do is that they directly give you in the structural drawing. Like example, if I go back to the drawing now, yeah. Hmm. So if I go back to the drawing, so see, this is the typical, okay. So in some of the cases, whatever length we have here, no, this length you can see, people will measure this. I mean, a structural consultant, usually sometimes he is going to give, like you can take directly 12 inches or 300 mm. In that case, we'll directly consider this. If it is not given, in that case, what we are supposed to do, in that case, we'll take the overall depth of the foundation, and from there, we'll deduct the bottom cover, which is 50 mm, and we'll deduct the top cover, which is 50 mm. So in that case, this particular thing will come somewhere here. Now, there are few other people, what they do, they I'll tell you one more method. See, now this bar bending schedule, you don't have any fixed method. It depends on the company where you're working. It depends on what procedure you're adopting. I'm explaining everything. Tomorrow, when you start to work, if your company is following this, then you can go ahead with this. What few people do, overall depth is 400 minus top 50 minus bottom 50. How much answer you got? You got 300 mm. Now, for this 300 mm, they'll multiply by 75%, or they'll say 2/3 of this depth we are considering, 2/3. Okay. So that also few people do. That is 2/3 is 0.7, 0.67. 67% they are going to consider. So you can do that also. That means into 300 into 0.67. So I'm getting 201. I'm getting 201 mm. So this height, whatever we got, no, this height, we got, no, this will be 201 mm. So few people follow this also at the side. So it's totally depend on what you people are following in your site. Okay, you can follow any method which you have given. Okay, but most of the people follow the same method. That is, whatever top cover minus cover, and 2/3 of that they are going to do. And same thing in the Excel sheet also, I've done the same thing. If you see here, I've taken 2/3. I'll explain you later. Okay, but this is a normal construction practice what we do. Few people don't add 2/3, and they directly deduct the top cover and the bottom cover. Okay, so it totally depends on the company that you're working for. Okay, great. So now what I've done in this calculation, I haven't done in that way. I've directly taken 300 mm, but I'm showing you all the cases. Okay, great. Now, if I get the development length, this one side it is 300, here also it is 300, and this length already I have found. So the total cutting length will be 1750. That is this straight length 1750 plus this 300 plus this 300. So 1750 plus 300 plus 300. So which will be 2350 mm. Got it? So this complete cutting length of one bar is 2350. So I have found the cutting length for one bar. But how many bars are there, that I don't know, right? If you see here, there are so many bars, like 1, 2, 3, 4, 5. I don't know how many bars are there. How do you find the number of bar? So always remember, whenever you're supposed to find the number of bar, the shorter side number of bar will be, always you have to take the opposite side. If I'm taking shorter side, it has to be longer side. minus 2 sides the cover, divide by the shorter span spacing plus 1. Okay. So this you have to remember this formula. If I'm finding a shorter span, I need to take the opposite, that is a longer side. Suppose if I was finding the longer span in further slides, I'll show you that. See here I'm taking a longer side. In that case, the formula will be shorter side minus 2 side the cover, divide by longer span spacing plus 1. Okay. You just have to remember this, and then it is very easy. So the shorter side number of bar will be, what is the longer side? So this longer side is 2050. This is 2050 minus 2 sides the cover. Again, here also I need to deduct 50 mm. From here also I need to deduct 50 mm. 2050 minus 50 you do, and that you divide by shorter span spacing. So shorter span spacing, it's given 185 center to center spacing. That is the distance between these two bar is 185, 185, 185. So I'm dividing this by 185. Try to do it manually. How much you are going to get? So it will be 2050 minus 50 minus 50. 1950. So 1950 you divide it by 185. I'm getting 10.54. So how much I'm getting? 10.54. So since it is 10.54, I can consider this as 11. And always we need to add plus 1 to that. So it will be 12 numbers. Why plus 1? Because right now, whatever we are considering, no, it is a spacing. See, this is 1 bar, this is 2 bar. But in between this 2 bar, we consider this as spacing. But how many bar are there? 1 and 2, isn't it? So that is why whenever you find the number of bar, always you have to add 1 in the bar bending schedule. Not only in the footing, further when we do the beam, the column and all. So always in the stirrup and all, we have to add 1. This you have to remember forever. Okay. And what is the reason behind that? The reason is, see, bar is how much? 1 bar. I'll show it here only. See, how many spacings are there? 1 spacing, 2 spacing, 3 spacing, 4 spacing. I'll do it in this way. Okay. See, 1 spacing, right? 2 spacing, 3 spacing, 4 spacing. Okay, I'll do it in a better way, because what happens is after some time people ask me the same doubt. So that is why let me make it clear. This is 1 spacing, this is 2 spacing, this is spacing number 3, spacing number 4, spacing number 5, and spacing number 6, right? Spacing is 6, but when you're finding the number of bar, count how many bars are there. This is 1, no? This is 2, no? 3, 4, 5, 6, and 7. So that is why spacing you had 6, but number of bars are 7. So that is why whenever you find the number of bar, always add plus 1, right? So that is why I've written plus 1 here. So if I do that, I'll get 12 number of bar. So shorter side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bars I'm going to put. So practically I'll be putting in this way 1, 2, 3, 4, 5. Okay, in this way, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bars I'll put only on the shorter side. The longer side I didn't calculate. For the longer side, again, I'll start with the longer side now. So the cutting length of the straight portion along the longer span now. What is the span we have? 2050, isn't it? So the longer span is 2050, but we know that this length, if I want, what I need to do? Overall length 2050 minus 50 from the right side, minus 50 from the left side. So 2050 minus 50 and minus 50. How much it comes out to be? 1950 mm. Fine. Now this I don't know. This is development length. This is also development length. So development length, I'm considering here 300 mm by default for our understanding. But when I take the real projects, we'll apply the concepts and I'll teach you. Always remember this, whatever we have, it totally depends. Okay. 300 mm, how did I get? Because overall depth is 400 minus top 50 mm minus bottom 50 mm. So 400 minus 50 minus 50 will be 300 mm. Okay, great. Now the total cutting length, can you find? Obviously, this length, you know, this length is 1950 plus this is 300 mm plus this is 300 mm. So 1950 plus 300 plus 300 is 2550. So this is a total cutting length of 1 bar, which is 2550. But how many bars are there? That I don't know. So therefore, the longer side number of bars will be always longer side I took. So your formula will be opposite side, that is shorter span. So longer span, if I want to find, I need to take the shorter span minus 2 sides the cover, divide by longer span spacing plus 1. So what is the shorter span? Shorter span is 1850. This is 1850. So 1850 minus 50, because this 50, see, I'll explain you why this minus has to be done. But now understand it, minus 50 minus 50. And you do this, you'll get 1750 divide by longer span spacing. So longer span spacing is 205. So divided by 205. Let me do that. How much answer you're getting? So it will be 1750 divided by 205. I'm getting 8.53, which I can consider it as 9 number. So 9 plus 1 will be 10 number. Got it? So in this way, you're supposed to do the bar bending schedule. Now you may ask me one question. When you're finding the longer side bar, you're taken shorter span. I agree, sir. But why you are done two side cover? Again, for a very same reason. See, this 1850 is from outer of this footing to outer of this footing. But when you're placing the bar, is your bar exactly at the outer? No. From outer, you are left 50 mm cover. From here also, you are left 50 mm cover. That is why shorter span, that is overall length, minus 50 from this side, minus from 50 from this side. Okay. To put it in a better way, you get an idea here. I'll show you here. See here. Okay. This one. When you're calculating this overall length, minus 50 from here, minus 50 from here. That means, see, if I want to find how many bars are there, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to find how many bars are there. If I want to find this bar, which length I'm supposed to take? I'm supposed to take this length, okay, from this outer to this outer. So let us consider this outer to outer length is 1850. It is 1850. So 1850 overall length, outer to outer, minus from here you have to leave 50 mm, and from here you have to leave 50 mm. See, this first bar, whatever you are placing, no, is it that it is exactly at the outside of the footing? No, we are left a 50 mm cover. In the same way, this last bar, whatever you can see, is it exactly at the outer of the footing? No, you are left a 50 mm gap from here. So that is why in the formula, always remember this formula. See here also, shorter span minus two sides the cover. Okay, that's it. So once you find this, you will get the number of bar. And if you multiply this by the unit weight, what is that unit weight? We are written, no? If it is 8 mm bar, you have to multiply this by 0.395. If it is 10 mm bar, you are supposed to take 0.617. So in this way, if I multiply, I'll get the total weight of the bar that is required. Got it? So I hope you have understood the concept here, how it has to be done. And in the next lecture, I'll teach you how this Excel sheets has to be done. Previously, we have done up to here, right? Now, after that, I'll teach you how this Excel sheets has to be prepared and how we can input all these things. Now, one doubt may come in your mind. Sir, we have seen in many videos and all that people take this thing, bend deduction. So what is that bend deduction? Bend deduction means, see, this is a straight bar what we have. But when we bend a bar in this way, this is my 90-degree bend, right? So this angle what it is created, is 90 degree. This is 90 degree. So whenever you are bending a bar, what will happen? Here, there will be increase in the length of your bar. So according to the code, it is written, if you're bending your bar in 90 degree, you have to take 2 times the 2D deduction, 2 times the diameter of a bar you have to deduct from the overall cutting length. Suppose if you're bending your bar in 135 degree, you have to take 3D deduction, 3 times the diameter you're supposed to deduct. Suppose if you're going for 180, you're supposed to take 4 times the deduction of the bar. And suppose if it is a 45 degree, it is 1D. Suppose if you're bending your bar in 45 degree, it has to be 1D. Okay. So according to this logic, you can see this is a cutting length what we got, 2550. This cutting length what we got is 2550. But since I have 190-degree bend here, I have another 90-degree bend here. So how many bends we have 90 degree? 1 and 2. So 2 bends we have, right? So two 90-degree bends we have. And according to the logic, if you have 190-degree bend, you have to take 2 times the deduction you have to take. So that means, according to my calculation, how many bends I have? 2 I have. So 2 into how many deduction? If it is 90 degree, 1. We have 2, no? So 2 into 2D I'm supposed to do. So 2D means it becomes 4D. And what is D? D is the diameter of the bar. So what is the diameter of the bar given? Here it is 12 diameter given. So that will be 4 into 12, which comes out to be 12, 20, 48 mm. So whatever cutting length I got, no, 2550. So 2550 minus 48 I'm supposed to do. If I do this, no, this will be the actual cutting length of my rebar. That is 2550 minus 48, which is 2502 mm. But I didn't do this because, see, now again the same thing. Few companies follow this, few companies don't follow this. Okay. So it's totally up to your company which what you follow. But I've taught you both the example. If you want to add the bend deduction, you have 2D bend, so minus that 4D from the cutting length you have got. If you don't want to do that, keep it as it is, not a problem. Okay, so all these things will be discussed at the time of the project only, because when you're taking up a project nowadays, what is happening, most of the contractors and most of the clients, they say in the beginning itself that will not do this bend deduction, and based on that we carry out the bar bending schedule. Okay, now there are few people who say no, we don't follow that, we want to add the bend deduction. If that is the case, then you add the bend deduction. Okay, so in all my thing, in all my Excel sheet, whatever I taught you, I haven't taken this bend deduction, but I'll teach you how a bend deduction has to be applied, not an issue. But you should be knowing everything. Okay, because what happens tomorrow, you should not tell that I did not teach you. So it all depends on the company that you're working for. Few people follow that, few people don't follow that. Like always give example. See, when we do any design of a structure, okay, when we do any design of a structure, let us consider if this is my beam, okay, and on this beam, we did a calculation, and let us consider this is a uniformly distributed load which is coming on the beam, and we did a calculation, and we found that the uniformly distributed load is 11.73 kilonewton. Okay, so but 11.73 doesn't look good. You can take it as 12 kilonewton. Now what happens? Few people add 11.73 only. What few people do, they add 12 kilonewton. And even there are few people who say even though it is 11.73, in real structure this much load will not come. Instead of 11.73, we'll make it as 11.5. Now you tell me who are wrong. No one is wrong in this. It's totally their judgment what they are doing, and they have been following this. So the person adding 11.73, he is also correct. The person who is adding a live load, or let us say UDL of 11.75 kilonewton, he is also correct. And the person who is adding 12, he is also correct, right? So there is no one is wrong. So these are the different theories, or these are the different principles. We always call this as two school of thoughts. So it totally depends on you. Okay, now no one is wrong. In the same way, when I'm explaining you this bend deduction, it is also same thing. Few people follow that, few people don't follow that. So I've explained you both the method, and both are correct, right? Yeah. So I hope you have enjoyed my lecture up to here. So in the next lecture, I'll teach you how this Excel sheets has to be prepared, and then we'll go on inputting the values, and we'll try to see how the Excel sheet linking has to be done. So in this lecture, we will try to see how the BBS sheet has to be prepared. So up to here we have done, isn't it? So now we are supposed to do something like this. Okay. So again, see, preparing an Excel sheet is not common. Each people have their own way of doing. I'm teaching you this method. If you feel you have any better method than this, you can follow that. End of the day, we want the answer to remain same. That's it. The way you prepare the Excel sheet is completely different, and we don't have issue with that. Okay, fine. So how do you prepare a shape, something like this and all that we'll try to see. So what I'll do, I've written a serial number, something called a shape of bar we have written, bar description, number of bar, dia of bar, spacing and everything we have written. Okay, so now what I'll do, I'll try to make a shape here. So for making a shape, how I usually do, you see here, this is a shape of the bar we have. Okay, this is one row I have. Next, on the left side I have one more row, on the right side I have one more row. So in that way, what I have done, I prepare this shape, and then I utilize this row to write 200. This row I have utilized to write 200, and this particular thing, okay, I mean this column and this column, and this row I utilized for this. So the same thing I need to do here, whereas you can see I have only one column. So what I'll do, I'll insert one more column on the left of this shape of bar and on the right side, so that we can make our Excel sheet similar to this. Okay, fine. So right click here, and there's option called as insert. We add insert to that. So you got one row, one column added on the left side of the shape of the bar. In the same way, I want one more column to be on the right side. So I'll click here and I'll say insert. Okay, done. So you can see this is a shape of bar. On the left side, I have one column. On the right side, I have one column. Now I'll decrease the size of that. Okay, only this much is enough for me. And similarly, here also, this much is enough. I mean, yeah, this much is enough. Can reduce the size of this. Yeah, try to keep it equally so that it looks good when you prepare the Excel sheets. Yeah, so very similar. Now this part you can merge. Okay, since you added one, you merge it in this way. Fine. Now everything looks good. Even here also you can merge it. You merge it. Okay, fine, good. Now serial number is done. Shape of bar, part description. First we'll start with the shape of the bar. Okay, done. So how we are going to do that again, I'll see here. Okay, so first I'll teach you. First we'll do this one. Okay, first I'll tell you how it has to be written. F1 footing, again see, few people write all these things, few people don't do. I'll teach you different ways. What few people do, they just write here F1 footing, like yeah. So where do you find that? See, come here, this is a drawing what we had, isn't it? And in this drawing it was written here, where is that F1 footing, what is the size? So this F1 footing, which is 1200 by 1200 by 400. Okay. So same thing I'll write here. So you can write directly here like F1 footing, and you can write 1200 by 1200 by 400. This is one way of writing. Few people write in this way. But what I've done, I didn't do that. I've written something like this. Okay. Where I made use of this complete row, and I've given it something like this. Then I've mentioned like L is 1200 and this breadth is 1200 and depth is 400, because I've interlinked my Excel sheet in that way. Okay, so I'll teach you that only, how it has to be done. Yeah, so once I've written this, I'll just yeah, this thing, and now I'll just merge it. Okay, see, selected in this way, and then I've written merge at center. Okay, this has been merged. So now here I'll write that okay, this is my L, and okay, fine. So I'll write it in this way, that this will be my 1200. Okay, and okay, then this will be my okay, in that I'll take it out. Otherwise I can do one more thing, I can add the color to that. Wait, let me do that also. What I'll do, no, I'll see this. Okay, what I'll do is I'll just select in this way. You do one thing, you select this part in this way. Okay, and once you select, come here, you put this white color to that. Okay, you're getting my point, you put white color to that. Now what has happened, see, this is how it looks. I'll teach you one more thing. See, now if I do in this way, it doesn't look good, no? So see here how I've done, everything is white in color, no? How do you do that? It's very simple. What you have to do, just select this much portion right now and just drag it. Okay, enough, up to here it's enough. And then come here and select the white color in this. So once you select the white color, this is how it looks. Now you can do the way you want. I selected this and I'll give a thick border to that, thick outside border. Okay, and now we can write this, that this is length. This part you write here, you write this as capital L, that this is length, and this is for breadth, and this is for depth. Okay, and then if you want, select that, bring it at the center, I mean bring them at the center, and give a thick box, and then you can increase this font also, and then if you want, you can increase the size of that. Okay, and then now what we can do, individually we'll write it, thick box. Okay, so length, breadth and depth is also done. The same thing I've done it here, length, breadth and depth. If you want, you can even decrease this size. This one, you bring it little closer. Okay, yeah, I think this much is enough. Now it looks good. Okay, then now what is the size we have written? 1200 by 1200 by 400. Write your length, which is 1200. Your breadth is also 1200, and your depth is also how much? 400. Once you're written, again you select that, give a thick box, change the font. Okay, and then yeah, bring at the center, make it bold, and you can increase the size, and then accordingly you can do it in this way. Done. So length, breadth, depth, you've written everything. Now it looks great, isn't it? Fine. So once these things are done, next you have to do a shape, something like this. This is a shape what I've done. So how do you do a shape something like that? I'll teach you. Before that, we'll try to give this thing here, this part and this part will say all borders. Okay, say all borders. So the borders will come. Okay, now it will look good. Later we can take it out. Yeah. So once this is done, we'll make a shape here itself. Okay, so for making a shape, what you're supposed to do, yeah, so what you do, you go to the option called as insert. Okay, so in the insert, you have to come to this illustrations, and this option called as shape. Click on the shape, and you have to click on this shape. Okay, I'll repeat it once again. What you're supposed to do, go to the insert option, and in the insert you come to the illustrations, and here there's option called as shape, and click on this line. Okay, fine. So once you click on that, wait, let me Add it once again, insert, illustration, shapes and this line. Now you decide how you want to keep it, shape of the bar. Okay. So the first I'll go with the shorter span. I mean, it's anything is okay. You just have to create a shape here. Okay. So what I'll do, I'll create a shape in this way. Okay. So when you drag it, no, it won't be exactly orthogonal. I mean, it won't be exactly straight. So you can click on the shift button, shift in your keyboard, and then drag it. It becomes vertical. You're getting my point? If you leave shift button, it will tilt in this way. Click on the shift, SHIFT, and then drag it. So just have an idea to what length you require. This much is enough for me. It looks great. So I'll keep it in this way. So this is done. Okay. So once this is done, next what you can do, again you can come here, and again you come here, and you can take the same thing. Else you can do one more thing. So the line what you have put, no, it is very thin. Okay, I mean it is thin. So if you want to make it dark, click on this. Okay, click on this and come to the home, and here there's option to increase the shape format and shape outline. You're getting my point? You have to click on, see, first you click on this, come to shape format, shape outline, and there's something called as weight. Click on that and do it in this way. So this will look good. So click on that. So it become dark, isn't it? Now this color also, if you want, you can change. I've kept it blue here. If you want to change it to the black, click on that, come to the shape format, and here shape outline, and now you select black. If you want red, keep red. I'll keep black, and it's okay. So black, I've kept it. So once you're done with this, again use Control C and Control V. Okay, and now this time you put it, you just drag it in this way, keep it here, join it. Okay, and up to this distance you take. You don't take up to here, because this is one row, this is second row, this is third row. I want this to come here, this horizontal to be in between this. Okay, I'll keep up to here, it will look good. Okay, fine. So 2 is done. And next again you control, keep your mouse here, select this, Control C and Control V. It will get copied, and you paste it here. Okay, so this is not exactly horizontal. So click on the shift button, or you can even drag it in this way. Yeah, now it's okay. And just join this. You can see I got this shape. Okay, I think it's not exactly horizontal. Just try to make it horizontal. It will come. Okay, yeah, now it's okay. Try to keep it in this way. Your shape is ready. You can see how I've done it. Okay, I've done it in this way because this whatever I've created, no, that is little thin. Here I made it little dark. If you don't want this much thick, again select this. Okay, go to shape, click outline. I mean, come to the weight part, and you can click on this now. This also looks good. Keep on this. Now you see it is little thin. No, it looks good. Now you do one more thing. When you select, no, so this is a different part. This is a different part, and this is a different part. So what you do, click, select, all the three you select, right click, the option here called is group, and you group it. So once you group, no, see, it will act as a single unit. Now you can drag and keep it anywhere. Okay, I'll repeat that method again. What you're supposed to do, click on this, click on this, click on this. Okay, shift. You have to select the shift, you have to select the control button, and then you have to like select this control button and select this. Press the control button in your keyboard and select this. Okay, once all three are selected, right click, go to the group and group it. Finish. So the grouping is done. Now it will act as a one single unit. You can drag it anywhere. Fine. Yeah, so this shape is done. Okay, done. So once this shape is done, next what you're supposed to do, next we have to write the bar description. What type of bar is this? So again, for that I'll increase this, because this much space is not enough. I need to increase. So I'll write this as shorter span bar. So it's written shorter, no? See, F1 bar along shorter span. So I'll write it here that this particular bar, whatever I've drawn, it is actually belonging to F1 footing, and it is a shorter span bar. Okay. So what you can write here, I can do it in this way. I'll select this, okay, and I'll merge it. Merge at center. So I'll write here F1 bar along shorter span, so that it will easy for you to identify what kind of bar you put here. And then you take it to the middle part, make it bold, and if you want, you change the font of that. Okay, great. So now it looks good. No, you can take at the center also if you want. Done. So this is along the shorter span. Now in the same way, along the longer span also you'll provide a bar, right? If you see the drawing again, this is the footing. I've done the shorter span. Now longer side also you'll put a bar, no? So again, I'll write a longer side. Again, I'll control C and I'll drag it. This will be my longer span bar. Okay. This will be my longer span bar. And I'll write here. I'll drag this and I'll write here. Merge at center. And I'll write what I'll write. Again, F1 bar along longer span. Okay. Done. Okay. F1 bar along longer span. Okay. Along longer span. Along longer span it should be. This also should be F1 bar along shorter span. Okay. Yeah. Now again, you change the font of it. And yeah, now it looks good, no? Great. So most of the things we have done now. Other than that, all these things we have to do a input. Now, once you're done with this, what we'll do, we'll try to make a bit decoration here. I mean, we'll make it little good. Okay, fine, enough. So now you know how to find the cutting length. How do you find the cutting length? Tell me. This is shortest span bar, right? How do you find this length? So this length will be how much? So 1200 minus 50 on the left side, minus 50 on the right side, isn't it? Right. So how do you write? So you have this option here, plus symbol, open the bracket. So click on this 1200. This is shorter span, no? This L is longer span. B is shorter span. So select this 1200. Minus, on the left side you have a 50 mm cover, and on the right side you have a minus 50 mm cover, and close the bracket, hit the enter button. So you got 1100 here. You select this and come to the this portion. And now if you want, increase the size of that. So this is your 1100. Got it? You are getting my point, no? This is 1100. How did you get this 1100? Because my shorter side is 1200. So 1200 minus 50 on the left side, minus 50 on the right side. Okay? You know, because already these things have made it clear. How do you find? Same thing I've done. It was 2500, let us say, along the shorter span. So 2050 minus 50 on the left side, minus 50 on the right side. The same thing I've done in Excel sheet. Otherwise, for your understanding, what I can do, I'll do one method. I'll use the same this thing, that is 2050 and 1850 and 400. I can do that also, but not an issue. We'll go with this only. I hope you're able to understand. So this is done a shorter span. Now this L I don't know, and this L also I don't know. How do you find that? I told you, whatever is the overall depth, minus 50 mm on the top side, minus 50 on the down side, bottom cover will give you this one. But again, I told you, in few of the construction practices, whatever answer they give, they multiply that by 2/3 of the depth. 2/3, right? So if you remember what I told, overall depth is 400, minus 50 on the left side, minus 50 on, I mean, minus 50 from the top, minus 50 from the bottom, right? So this is the actual answer you're supposed to get. But again, what few people do, whatever answer they get, for that, they consider only 2/3 portion. That means this will be 0.67 into this answer is what they try to do. Enter. So this is 201 mm actually. So here also we'll apply the same logic. So the logic is again, what I'll do, I'll select this two. Yeah, and I'll merge it. Okay. You merge it at the center. Okay. And right here. What they did, plus open bracket 400. You have to take 400 from here only. Don't write 400. When you're interlinking, if you change, everything will change later. So 400 minus top cover 50 mm minus bottom cover 50 mm. Close the bracket and multiply this by 2/3 or 0.67. Okay. And hit the enter button. See, 201 I got manually. Here also I got 201. Now again, this is not looking good. No, actually 201 is this one. So click on this, go to the home option, click on this now, align left, and now you come to the top. Now is it looking good? Exactly. This is 201. If you want to increase the size of this, come here, make it bold, and yeah, make it this one. It looks good. Now again, this is also 201, because if this is 201, obviously this is also 201. So again, here you select in this way, okay? And then you merge at the center. Got it? And now what you do, again, you don't have to write plus open bracket, interlinking this 400 minus 50 minus 50. Okay, minus 50, close the bracket into 0.67. Nothing, this you don't have to do again. Simply what you do, you just interlink. Interlink means plus, just click on this cell and hit the enter button. Simple. So what will happen? Whatever answer you get here, the same answer you're going to get here. And now you make it alignment. Again, click on this, come to the home option, come to this center portion, come to the right side and make it dark and come to the this portion. Is it looking good now? Exactly, it looks good. So this is the least what we can do. I've taken completely to the right. So it looks good, not an issue. Okay. If you want, you can actually pull a little bit on this side. Yeah, now it looks good, right? Huh. So that's it. If you want to change the color, no, change the color because everything is looking in black in color. Only the answers I'll make it red in color. So I'll make red in color. Got it? No? Fine. In the same way, whatever you have done on the shorter span, this is shorter span. Now I'll do the along the longer span. Okay. So for the longer span, how we are going to do? Again, select here, plus open the bracket. Now you tell me along the longer span, what is the length I'm supposed to take? L is longer span. So 1200 minus 50 on the left side, minus 50 on the right side, and close the bracket, hit the enter button. So again, it will come 1100 only. Why? Because both were 1200, no? But in future, that means in further, when I go again for different footings, I'll explain you how it's going to change. But in our drawing, everything is same. So answer is coming same. So again, select on this, come to the home page, come to the center part, make it bold, and this part. Got it? Great. Fine. Now this part, what you're supposed to do, again, this part, since for the shorter and longer, both footing, this will remain same. That means 201, whatever you're getting along the shorter, no, here also you should get 201. So best trick, what you can apply, you just click here, I mean, select this portion, this two cell you select, okay, okay, this two select, this two also you select, and you say merge at center. Okay, great. And now you select, keep your mouse here, plus you just click on this one, 201, and hit the enter button, finish. Okay, what will happen? Whatever answer you get here, same answer will come here. Again, same thing, plus whatever answer you get here, same thing will come here, fine. So in this way, what will happen everywhere? If you change this one answer, everywhere it's going to change. So this is the power of Excel sheet. So if you don't want to do in this way, you can again write here. Okay, you can write what you can write, plus 400 minus 50 into 0.67 you can do. But again, since we are using Excel to decrease our workload, so that is why you need to be a bit smarter. So that is why if you try to interchange, everything will remain. I mean, if you try to interlink in this way, so your answers will be right. Okay. Then again, what you do, you change the color of this now. Go to the home, make it color. I mean, change the color of that. Okay, and then make it bold. And now we'll bring this at the center. I mean, this one to the left side. Go to the home page, bring on the left side, and this you click on this. Go to the home and bring it on the right side. Finish. It looks good, no? This part you can pull a bit. Yeah, now it looks good. Great. So everything we have done. So now you understood how this bar shape has to be done. See, whatever I did here, I have done everything here. The same thing I have taught you how it has to be done. Now you're okay with that. So you can follow this method and you can do it. Okay. Other than that, there is one more method. That is, you can go to insert, home, and here there is something called as draw border. But this will work. See, in this also you can, in this way also you can create a bar shape. This is actually a very easy method to, most of the people try to do in this only. That also can be done. Okay. I'll teach you one more method. Okay. What is another method? Instead of going here, going to the insert and taking these shapes and all, no, this shape I taught you. Instead of doing that, what you can do, okay, what you can do, come to this option called as this one, okay, border. Here there's option called as draw border. Okay, select this and select this, whatever shape you want. Select on this point, select here, and click here. Finish. Your shape is ready. Done. This I'll delete. Okay. If you want to delete, no, you cannot just click and hit the enter button. I think that delete won't happen. Click on that. Go to the home page. Again, you have to come and say no border. You have to say erase border. Again, you erase the border. In this way, it will get erased. Okay. Fine. Now, once you do this, again, select on this. Go to the home option. Come to this portion. Where was the border? Yeah, this was the border. No, where was the border? Wait. Yeah. Select on this. insert, draw. Yeah, I'm not getting the border option. Okay, no problem, because I need to increase the size of this. So I need to select on this, go to the home option, and then from here I need to increase the size of this. Okay, I think not getting where it is now. No problem. I'll tell you how it has to be done. Okay, fine. So I hope up to here your concepts are clear. You know how it has to be done. Okay. So this should have come. Insert option is not coming. Okay. Or come to the draw border. Yeah, it's here. Fine. Okay. I'll select this. Okay. Come to the home. Come to this option. And here you can see line color. This color you can change from here also. I'll make it red. See, this will become red also. That also can be done. Along with that, you can select here and you can increase the this thing also, thickness also. See, you can even make this as more bold. See, this also can be done. You're getting my point? So you can follow any method. I think the one which I explained you now, no, this is very simple. Rather than creating the line and all, you can even follow this method also, because this method will not work every time, because tomorrow in the next lecture when I teach you how to prepare this shape like stirrup and all, no, then this border will not help you. In that case you have to go to the shape option only. Okay, I hope you have got an idea how it has to be done. So both things are done. I've explained you this and this. Okay, fine. Other than that, and now coming to the number of member, the dia and all, I'll teach you in the next lecture, because again it will take a very long time for me to explain everything. But in the next lecture I will finish one BBS of a footing, where right now we have learned up to here how to prepare the Excel sheet, how to prepare this shapes and all. You follow the second method, that is a draw border method, or even you can follow my first method of putting a shape, bar shape and all. Everything is possible. It totally depends on you. Whichever you are comfortable, you can try to do it. So that's how it is. So in the next lecture, we'll try to do all these things: number of bar, dia, spacing. We'll try to find the number of bar, the cutting length and all. So up to here, finish the Excel sheet, because if you prepare this Excel sheet, rest your work will be very easy. So we'll see you back in the next lecture. So in the previous lecture, we had done up to here, right? Now we'll try to fill all this number of bars, the dia of bar and so on. So for that, you need to make a little bit of adjustment in the Excel. Now you see, because I have written F1 here and F1 bar along longer span here. That means whatever value I'm going to fill, it should come in between these two, right? So this is that one. What I'll do is I'll select that. This part let me select, and I'll go to the home page and let me give a thick border to that so that it is easy for me to identify. Okay. Similarly, here also I'll do it. Fine. So along with this, what you can do is see, now if I write here, no, it will come on the top. So instead of that, I'll merge all these things at once. Okay. So that it will be easy for me to write exactly at the center. See, again, all these things depends on you, whether you want to do it or not. Just to make our Excel sheet more what do you call, to look it in a better way, we are trying to do this. If you want, you can do it, else you can just write, because if you're practicing it for the first time, concentrate on solving the Excel, and decorating it can be done even later also, not an issue. Okay, but since I'm teaching, I'll teach it you. I'll teach both the things together. Yeah, so this is also done. I'll make it thick. So now you can see everything looks good. Okay. Yeah. So again, another one thing is, see here again, I don't require anything. Okay. I'll select this, or I can do one more thing. Come here, take this, yeah, white color. Wait, what you can do is select this thing up to here, and then you can fill that color, I guess. Yeah, you can fill this in white color, and that also will be gone. Okay. Now it will look good. No, even this part also, if you want, you can do, else let it be, not an issue. Okay. Done. Now we'll try to find F1 bar along shorter span. So first is number of members. Number of members means how many F1 footings are there. So for that, we have to go to the Excel sheet always. So in the Excel, if you remember, initially we had written like F1, there is only one footing, right? So I'll write here F1 is only one. So that is 0, 1. Or you can write 1 also. I think same thing I've written here. Okay, fine. See, when you write 0, 1 here, it will come at the bottom. No? You take it to the top. Select this. You know this option. Select this option. So instead of doing it every time, what you can do is select everything here and you select everything here. Now come to the home page. First you change the font, make it to this one, and now you take this at the center. Okay, yeah, take it at the center, and if you want you can make it bold, so everything automatically it will get updated. Okay, one. Now here also it is one, no, because say this is shorter span, this is longer span. Whatever you write here, same thing should come here, so you interlink it. Interlink means again don't write one here. Instead of writing one here, keep your mouse here, plus, and click on this and hit enter, finish. So if I write 2 here tomorrow, automatically it will get updated. Okay, so that is why you have to interlink as far as possible in the Excel sheet. Try to interlink. Next is dia of bar. So again, dia of bar in the shorter span, we should check the drawing. So I'll go back to the drawing. So this is my L1. Okay, see, always remember I have written here shorter span and longer span, but in Excel, in AutoCAD it is mentioned L1 and B1. So wherever L is mentioned, it means it's a longer span. B means it is a shorter span. B means along the breadth. L means along the length. So length it is 10 diameter bar, and breadth is also it is 10 diameter bar. So both way it is 10 diameter. So we don't have problem. You just write here 10, and here also you write 10. Okay, and don't try to interlink this. Why? The reason is because in here luckily we have shorter and longer span both 10 diameter. There may be a chances in some of the structural drawing where you may have this 10 diameter, and let us say if this is 12 diameter. Okay, let us say if this was 12 diameter, then your longer should have been 10 diameter, shorter should have been 12 diameter. And if you interlink, what will happen? What if you interlink this? If I interlink this, okay, say let us say I'm interlinking, then it is wrong, no? Because shorter it is showing 10, longer also it is showing 10. So it will not make any sense. That is why always don't try to interlink the dia unless if it is same, then you can interlink, not an issue. But try to follow this procedure of not interlinking it. Okay, so now anyhow both are 10 and 10. I'll make it 10, and also this will make it as 10. Okay, yeah, great. So after that, next is spacing. Again, spacing come here shorter. So this is my shorter span, no? It is 150 center to center spacing. Longer is also 150. So both are 150. Again, you input 150 here. Here also you put 150. Okay, done. Next is number of bars. Yeah, how do you find the number of bar? So that is very important. So already in this manual calculation, I taught you how to find the number of bars. See, we'll start here. For if I want to find the bars along the shorter side, I need to take the longer span minus 2 side the cover, divide by the shorter span spacing plus 1, isn't it? The same thing we'll do it here. But here, how shall I do that? Always remember, whenever you are doing, yeah. So first I'll open the bracket plus open the bracket. So I'm doing along with span, shorter span. If I'm doing along the shorter span, I need to take the longer span. So in the longer span, see, I need to take this one. Okay, that is 1100. Why? Because this is shorter, this is longer. Okay, and here both length and breadth both are same. That is why you cannot find so much difference here. But anyhow, in future when I take another 2-3 problems, I'll explain you. But right now, remember, if you want to find the shortest span, if you want to find the bars in the shortest span, you have to take the longer span. Take this distance, 1100. Okay. Okay. Yeah. Okay. We'll directly take 1100, or we can do one more thing. Instead of doing that, number of bar, come here. Open the bracket. What is your longer span? My longer span is this one, no? 1200. Length. You take this one. Minus 50, that is cover on the left side, minus 50 cover on the right side. You're getting my point, no? And close the bracket. So that is what it was written here. Longer span minus 2 sides of the cover. This you can do. Otherwise, you could have directly taken 1100, because here already the cover is minus and taken. But we'll follow this method only. Okay, fine. And now once this is done, you divide this one by spacing. What is the spacing? Okay, this has come to this side. Wait, it will take some time now. Okay, okay. Bracket open. 2 times you open the bracket. So it is 1200 minus 50 minus 50. Okay, okay. Close the bracket. Okay, and put the divide symbol, because divide by spacing. Again, open the bracket. See, spacing actually it is 150, but here it has disappeared now. Not an issue. I'll manually input this as 150, or I can even write this. See, this is H, no? And this one is 15. H and 15 I need to write. So I need to write H15. Okay. Why did I write H15? Because it has to take this particular row, okay, this particular cell, but it has disappeared here. That is why I know this is H, this falls under H, and this falls under 15. That is why I've written H15, okay, and close the bracket. So once you do this, then what you're supposed to do, +1 and hit the enter button. So now it's telling yes. So your answer is how much? 8.33. So we'll do it manually also. We'll try to verify whether it is 8.33 or not. So again, I'll do it here. Okay. See, what is the spacing? It was 1200. Okay. 1200 minus 50 on the left side, minus 50 on the right side. So how much it will be? 1100. Great. So 1100 divided by what is the spacing of the shorter span? The spacing of the shorter span was 150, right? So try to do it manually. 1100 divided by 150. 1100 divided by 150. So I'm getting 7.33. I'm getting 7.33. So 7.33 means it is, we'll take it as 7 only. And for this, we have a formula +1, isn't it? +1. So 7 plus 1, it comes should be 8. So here it is showing 8.33 because it is 7.33 plus 1 it has done. So actually, it should come in a round figure because we cannot provide 8.33 bar. So for that, what you're supposed to do, you have to change the formula. Okay. In that, you need to add one thing that I'll show you. Already I've done it here. Okay. See, what you need to do, you need to write round up. Okay. Whenever you put a formula for number of bars in the Excel, first you write round up 1200 minus 50 divided by this +1, and then you have to write 0. Okay. I'll teach you here. Come here. So what we'll do, whatever you have written is correct. So now what you do, come here, right? Round up, ROUND. Okay, round up. Okay, once you write round up, this +1. Okay, +1, and now you have to write dash and 0. Why you should write comma and 0? Because now it is 8.33, no? So it will take to the next higher value. That is the reason you have to write comma 0 and close the bracket. So now you can see it has come 9. I'll explain you once again why I did all these things. See, if I go back here, okay, round up you have to do because if it is 8.33, it will be taking to the next higher value. Okay, that is why the roundup will be done. Okay, if it is 8.5, it will be taking 9 and all. Okay, now plus 1, you know how why it has to be done. Comma 0 means it will take the next higher value. You're getting my point. See, manually what was the answer we got? Manually we got 8.7.33 plus 1 was manually we got 8.33. Okay, 8.33 is what we got. But I told you round up means it will round up to the next higher value. What is after 8.33? What is the next higher value? The next higher value is 9, isn't it? Yeah. But how even 10 is also a next higher value. Why did it take 9 only? The reason is that I told +1, comma 0. So whenever I write comma 0, it will take the next immediate higher value, which is 9. Okay. Suppose if I had done here +1, and if I had done 2 here, it would have taken 10 here. That is not required for us. You're getting my point. So always remember, whenever you do Excel, okay, only for finding the number of bar, use this formula round up, and the same formula, that is this thing. What is that? 1200 minus 50 divide with the spacing along the shorter span +1, comma 0 you have to do. If you do in this way, you'll find the number of bar. You got my point? Great. So now coming to the cutting length. How do you find the cutting length? Now cutting length is very simple. You know this length, that is 1100, and if I add 201 to that, and if I add 201 to that, if I add everything, I'll get the total cutting length. Very simple. So we'll do the same thing now. Okay. So the cutting length will be, let me see what I've done here. Yeah. Okay. So we'll do the cutting length. Okay. So the cutting length will be plus open bracket. Come here. First you select this 1100 plus select 201 plus 201 and close the bracket. Hit the enter button. So the cutting length is 1502 mm. Okay. If you want to verify, try to verify it manually. Very simple. How do you verify? That is 1100 plus 201 on the left side plus 201 on the right side. So it will be 1100 plus 402. Okay. And if you do this, how much it will be? So it will be 1502 mm, right? Manual also we got the same thing. In Excel also we got the same thing. Yeah. Now in this, what we have done it correctly. But I told if you want to add the bend deduction, you can add the bend deduction here itself. Again, I told you in few of the projects people do bend deduction. In few projects people don't do bend deduction. But here anyhow, not an issue. I'll because in the previous Excel sheet, whatever I done here, everything the bend deduction has been added by me. So we'll follow the same procedure. And in one lecture, I'll explain you how you are supposed to do without the bend deduction. Okay, not an issue. So again, what you do for the bend deduction, you have to write minus, open the bracket. Okay, how many 90-degree bends are there? One is here, the second one is here. No, so 2D, 2 into 2 is 4D, right? So 4 multiplied by D. So what is the diameter? So diameter is 10. So again, don't write 10 here. Interlink this one, dia of the bar, and close the bracket and hit the enter button. That's it. 1462 is actually the cutting length after the deduction. And you see here also, I think we got 14. Okay. Okay. 1460 we got here. Okay, this is 200 what they have taken. We have taken 201 here. Okay, this is correct. What we have done is correct, not an issue. Okay, not an issue. So 1462 is what we got. Here they have got 1460. The reason is here it is 200 and 200, but here we have written 201 and 201. Okay, not an issue. We can do, we can even get it to that point also, but it's okay, not an issue, because yeah. So this will be 400, 300. And 2/3 of 300, they have rounded it off. That's it. 2 divided by 3.67 into 300. Yeah, then we also should get the same answer. We'll try to see. D1 400, D13 minus 50 minus 0.67, or even you can take this as we'll do this way. 2 divided by 3 we'll do, and we'll close the bracket. Yeah, see, now it's correct. 1460. I got 200, 200. Why did that happen? Because I told you the reason is that previously I took 0.67, and 2 divided by 3 is also 0.6667. So because of the decimal point, we were getting that 1 or 2 difference. So you can adopt this also. Directly adopt 2/3. It is also correct. Instead of writing 0.67, since it's Excel, no, it will take that decimal point and all. So you go with 2/3, which is the right formula to be adopted. Okay, not an issue. Fine. Now come to the cutting length. So whatever cutting length we have found, it is in I want it in meter. It's very simple. How do you do? Whatever cutting length you got, you divide it by 1000. Okay. You divide it by 1000 and close the bracket. So now you'll get it in meter. 1.460. Okay. If you want, you can increase the decimal of this. Yeah, 1 point. Okay, we'll keep it as 1.46 only. Okay. Now come to the total cutting length. So total cutting length is very important. So this 1.46 cutting length, what I got, no, it is for the single bar I got. So what will be your total cutting length? So total cutting length will be the cutting length of one bar. Okay. You multiply this by number of bar. Number of bar is 9. I'll do it here. See, cutting length of one bar multiply by the number of bar. So this will give me the total cutting length of the entire footing of F1 footing along the shorter span only. But how many such footings are there? We know only one footing is there. Okay, then 1.46 into 9 into 1 if I do, I'll get the total cutting length of the footing in one footing, in one F1 footing along the shorter span. You're getting my point? The same thing we'll do it here. So total cutting length will be plus, open the bracket. So cutting length of one bar, you multiply this by number of bar, and you multiply this by number of members, and then close the bracket and hit the enter button. So it is 13.14. How much we got here? Yeah, 13.140. Same thing. Okay. If you want, you can increase this, and this also you can increase. Done? Fine. That's it. Simple. Your calculation is done. Total cutting length we have found. Next, we are supposed to find the weight of the bar. So which is this? What is the diameter of my bar? It's a 10 diameter bar. Good. And what is the weight of a 10 diameter? It is 0.617. So the weight will be plus, open the bracket. Okay. Total cutting length. If I multiply this cutting length with the weight of a 10 diameter bar, that is 0.617, and then close the bracket, hit the enter button. So 8.11 kg is the total weight of my bar that is required if I want to prepare F1 footing of only one number. So 8.11 I got. Yeah, here also it is 8.107. If you want to increase this to 3 decimal point, it will be all right. Yeah, fine, not an issue. Okay, you can follow this. Yeah, great. That's it. Yeah, got it. So I hope, again, rest all these things, nothing. So you just put a dash symbol there. So this will be dash. enter. This will be dash, 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 enter. Finish. Next, come along the longer span. So in the longer span, what will happen? You have to find the number of bar, no? So number of bars, you tell me, open the bracket, great. Okay, round up we'll write later. Okay, not an issue. First we'll do this, later we'll write round up. Yeah, open the bracket, fine. So first you have to find the, I'm finding the bar along the longer span, so I have to take a shorter span. So shorter is 1200 minus 50 on the left side, minus 50 on the right side, bracket close. Put the divide symbol, again bracket open. What is the spacing? Spacing is again 150. Again, see, it got disappeared. It usually happens in Excel, not an issue. You just remember this H and this is 19. So write H19. So it will by default take that. Okay, fine. Now close the bracket. Okay, next +1 and close the bracket and hit the enter button. So again, it's coming 8.33. The reason why it is coming 8.33 is not, we have not taken the round up. So come here, write ROUND round up. So initially also you can write, okay. It's not that after entering only you have to write round up. Initially also if you do, it will come correct. +1. After that, give a comma and write 0 and hit enter button. Finish. You got 9. See, here also I got 9. Got it, no? Fine. Again, coming to the total cutting length. How do you find the total cutting length? Open bracket. So this 1100 plus 200 plus 200, close the bracket. Okay. So in this, you have to do the bend deduction minus open bracket 4 times the D. So 4 multiplied by D. Diameter is 10 here, right? And close the bracket and hit the enter button. Finish. Again, it is 1460, obviously. And this will be again open bracket 1460. You divide it by 1000 and close the bracket. Finish. 1.46. Now coming to the total cutting length. This also remains same. That is cutting length of 1 bar multiply by number of bar multiply by number of members. Close the bracket. Finish. 13.140. This you can increase the number. So again, it's a 10 diameter bar, no? So come here plus open bracket. Total cutting length of 1 bar. You multiply this, I mean total cutting length multiply by the unit weight of 10 die, which is 0.617, and close the bracket, hit the enter button. So you got 8.11. Okay. Finish. That's it. Next, what you're supposed to just you put this dash symbol here also. You see, it's up to you whether you want to put it or not. If you don't put also, it's okay. But when you put it, looks good. That's it. Finish. So that's it. We have finished one footing. Okay. F1 footing we have finished. So if I want to do F1 footing of 1200 by 1200 by 400, having a steel of 10 diameter at 150 along shorter and longer span, I require 8.11 kg of steel in the shorter span, and I require 8.11 kg of steel in the longer span. If you want to find the total weight, you just add 8 and 8.11 plus 8.11 will come out to be 16.22. So that is a total steel that is required in F1 footing. Now the magic of Excel is that let us consider in your drawing, instead of one number of F1 footing, I had 5 numbers. I had how much? 5 numbers. That's it. Come to the Excel sheet. Now let us say that happened. You prepared the Excel sheet and kept, but maybe after some time the structural designer or somebody changed the drawing, and he changed the drawing and he told F1 footing is not one. We have FI F1 footing. Then what you will do? You have to come here. In that case, that is why I've written BBS revision. Maybe a revision. You'll get a separate drawing. Initially, the drawing number was, let us say, it was 06. Okay. So when they revised, when this drawing got revised, okay, let us say instead of 1 footing, you had 5 footing. Drawing got revised. So you'll come here, BBS revision, you write. That is drawing number 1. Drawing number 6, you'll write here R1. R1 means revision 1. Okay. You're getting, this is the usual term what we write in structural drawing. Drawing number is 6. For that BBS drawing also is 6 only, but this is revision 1. So R1. Okay. So now what you do, come here, write 5 here and write 5 here. Finish. That's it. You see the magic also. I just gave 5 number here. The moment I gave 5 here, now automatically this also took 5 because it was interlinked here. And similarly, you see the steel also got changed. It came out to be 40.56 and 40.56. Okay, that's it. That's the beauty of using a Excel sheet and doing your bar bending schedule. Now, if you want to find the total weight, 40 plus 40 is 80 kg of steel is required this time. Okay. Anyhow, I'll fix it back to 1 and 1. Yeah, that's how it is. So you practice up to here. I've explained you for one footing. Similarly, I'm supposed to do for F2, F3, F4, F5, all the footings I'm supposed to do. So the method remains the same. But anyhow, in the next 2-3 lectures, I'll be taking up all those things because already I've prepared the Excel sheet and kept. Okay. And here I'll explain you all these things. And so that you will have a good understanding of the bar bending schedule. Okay. Try to practice it. Just there are 1 or 2 formulas which you need to remember. That is, I always tell, if you want to find the shorter side, longer side minus 2 sides the cover. This is a formula which is very important. And cutting length also I've explained you. In the upcoming lectures, I'll explain you a few basic terms about this thing, that is a bend deduction and all. And after that, we'll do this Excel sheet with the help of this bend deduction. And also I'll teach you without the bend deduction. And also this depth, whatever I've taken, that is 200 and 200. Here we'll not put 2/3 and 2/3. That also will do, because when I'm doing, I'll teach you all the method, and then totally depends on you what you want to follow. Okay, because few people don't do 2/3 here. They directly take overall depth minus top cover and bottom cover. That will be the L. Okay. So if in that case, we need to take out this 2/3. But usually most of the construction practices what we follow, we usually take 67% of that value. So that is why I've written 2/3. If you don't want to do that, you strike out this 2/3 from there. Similarly, your answer is going to change. Okay, fine. So we'll see you back in the next lecture. So once you're done up to here, no, next what you're supposed to do is you can try to see this already, whatever I done, I'll delete it. Okay. If you are done also, you can delete it. Come back here and say erase border, and you can erase it in this way. Okay. Yeah, erase it, and that's it. Finish. So now what we can do, no, we can even try to decorate it a bit. Okay. So in this way, you select everything up to here and say and give a thick border here. Okay, finish. So that means this entire thing is one footing, and this serial number you can drag in this way and say merge at center and write here serial number 01. Okay, so once you're written, it will come here. Click on that, take it to the top, and if you want, you increase the font of that. I mean, make it bold and then increase the font of that. Okay, great. Other than that, everything is great. Everything looks good. Not an issue. And later, if you want, you can bifurcate all this thing, but not required. This much is enough. Okay, fine. After that, one footing is done. We'll go back to the next footing. I hope up to here your concepts are clear. Now, I told you I'll explain you a few things here. See, why this bend deduction has to be taken, right? For example, here we have done 4 times the D. That is 4 into D. 2D bend here, 2D bend deduction here. What is the reason behind that? See, usually when you bend a bar, if you're bending, this is a rebar what I have, or a steel bar. When I bend this in the 45 degree direction, what will happen? There will be an increase in the length of this. So this increase in the length, we need to deduct from the original length. So whenever you're bending your bar in a 45 degree, you need to take 1D. That means 1D you have to do the deduction. For example, let us consider, if you're not understood the concept, let us consider before the bending, this is the length of my bar. Okay. And then I have bent my bar in 45 degree. This is my 45 degree bending. Okay, fine. So let us consider the length of the bar was 1500 mm. And when I bent the bar, so when I bent the bar, it came out to be 1505. Let us consider. Okay. So I'm taking a rough value. So what has happened? Actually, the length of the bar was 1500, but due to bending in the 45 degree, or let us say 1 minute, instead of 1505, no, I'll do this as I'll write this as a 8 diameter bar. Okay. Consider that it's a 8 diameter bar. The bar what I have considered is 8 mm bar. Okay. 8 mm bar. So this length, whatever happened, it increased to 1508 mm. Okay. 1508 mm. So what has happened? Actually, the length was 1500. Due to the bending, the bar has increased the length. The length of the bar has increased to 1502. But we want to deduct this extra length which has increased. This extra length we have to deduct. So that is why this formula has been crafted, which says that if you're bending your bar in 45 degree, you have to deduct 1D. So what is 1D? 1 into D is diameter of a bar. That means from the original length. Okay. From the original length, what is the original length? 1508. Due to the bending, this happened. Due to the bending, 1508 minus 1 times the D. 1 into diameter of the bar is 8 mm. Okay. So that means it comes out to be 1500 mm. You're getting my point? So that is why we were doing all this bend deduction. Okay. So in order to take care of this extra length which will increase due to the bending, we are applying this formula. Similarly, if you're bending your bar in 90 degree, so this is a 90-degree bend. Okay, you can see this is 90 degree. This is creating 90 degree. For that, you have to take 2D. For 45, it was 1D. For 90 degree, it is 2D. Okay, so that is why here you see this is 90-degree bend, isn't it? This is 190 degree. Here another 90 degree. So 290 degree has come. For 190 degree, if it is 2D, for 290 degree, 2 into 2D, that is 4D. That is why we what we were taking 4 into D, where D is the diameter of the bar we used to deduct. Getting my point? Suppose when we are bending it in 135 degree. So 135 degree comes in case of lateral ties and all. When we take up the column problem, I'll explain you there. Okay. There you are supposed to make use of 3D. Okay. And this 180 degree, usually when you're putting up a U-shaped bar and all, in that case 180 degree come. But most of the cases, whenever we do bar bending schedule, we encounter with 90 degree and this 135 degree. Okay. 135 degree where it comes, especially in case of the stirrup. So if this is my stirrup, then what happens? This particular area, right? So this particular thing, we bend it in this way. This will be 135 degree. So here we need to apply this 3D bend deduction. Okay. And sometimes whenever we put the lateral ties, it will be something like this, isn't it? If you have worked on the site and all, your lateral ties will be something like this. So again, this is also 135-degree bend. In that case, again, we need to apply this 3D and 3D. Okay. In future, we'll try to see. But now your concepts are clear. Fine. Now, there is one more school of thought to that. Few people don't follow this because they say that practically these things will not happen. There won't be 1 day increase in the length, and few people say that the whatever changes will happen. See, now if I tell here it is 1460. Suppose I'll copy the same thing, control C and control V. Okay, it won't work out. Okay, just remember it is 1460, 1460. And now if I don't do the bend deduction, so if I remove it out, okay, how much changes will happen? So it is 1500. That means hardly 40 has increased. So few people say that this 40 will not matter much, so we'll not take the bend deduction. Now few companies follow that also. They say that it's not much importance to us, and will not apply the bend deduction concept. That is also right, and there are companies nowadays who are following all these things. Okay, so that is why I always tell it all depends on the project that you're working for. Okay, there's no a fixed rule that you have to follow this only. This much is clear, but I've explained you the concept behind that. Yeah, great. So once this is done, next we'll go to the next this thing. What is that? Next footing. Okay, F1 is done. Now, when you're doing for the next footing, what you're supposed to do, you don't have to write again the same thing. Don't write again same thing. Just copy here. The same thing, you copy it in this way. You can copy up to here. Okay, copy like this. Okay, and say Control C. I've done Control C and come down. Okay, you start from here and say Control V. That's it. Finish. So this will be your footing number 2. Now this you make it as all the changes you do here. Quickly you'll get the answer. Okay, F2 footing. No, what is the size of that? F2 footing, it is 1400 by 1400 by 400. So input that. So it is 1400. So you see the changes now. Since we have interlinked everything, no, quickly you'll get the answer now. 1400 by 1400 by 400. You make this, the moment I make the 1400 and 1400, no, this everything will change. This also will change, and here also it will change. Okay. Now see the magic there. 1400 done. This go okay. This is 1400 done. This got changed. This is also 1400. This also got changed. Got it? Similarly, you see the answer also changed. Everything changed. Okay. Now everything again, you don't have to do any changes here because depth is 400. No, so that is why depth is 400. Fine. Now come to the diameter. Your shorter span, that is B1 is shorter. It is a 10 diameter at 150. This is also longer, is 10 diameter by 150. So here by default 10 and 10 I have written, 150 and 150 I have written. Finish. Your answer is ready. Only the thing is here what will happen, no? Since this input we have done manually, here this answer won't come because it will take the next value. You just come here and change the value. That's it. That means what you're supposed to do, no? You delete this part. Okay, wait, I'll tell you what has to be done. See, here what will happen, n24. So this is n and 24 is this one. So it will take some this value 24, which that is why you are getting 0 answer. So you come here, you delete this part. Okay, and it's a 10 diameter bar, no? Come here. So where is your 10 diameter? 0.617. Enter. Wait, come here. Okay. Multiply this by L30 is this one. That is total cutting length. We'll multiply the total cutting length with the unit weight of a 10 diameter bar and hit the enter button. Finish. You got 10.25 kg. Similarly, here also same thing. You delete this part. Okay, that means 16.600. Here also you'll get same answer, but still we'll interlink it and close the bracket, hit the enter button. Finish. So it is 10.25 kg. Got it? That's it. Your second footing is also ready. If you don't believe this, if you want, I'll do manual calculation for this quickly. Okay, you can do it because since we are in the initial phase, we'll try to manually verify sometimes. Okay, very simple. No, 1400 we know along the shorter span. If it is 1400, this will be 1400 minus 50, which is 1300, and this is 200 we know because 400 minus 50 will be 300, and for the 300 if I do 2/3 of the 300, 3 ones are 100, 100 into 2 is 200, exactly 200. So that means this is correct. Now come to the total cutting length. So total cutting length will be 1300 plus 200 plus 200. So 1300, 200 is 1500, 1500 plus 200 is 1700. So 1700 is a total cutting length. But here we need to do the bend deduction, which is 4 times the D. 4 into 10 we are supposed to do. So that will be 1700 minus 4 into 10 is 40. So that comes out to be 1660 mm, right? Manually also we got, in the Excel sheet also we got. Now if I divide this by 1000, I'll get it in meter. That is why 1660 divided by 1000 will give me 1.660 meter. And now in coming to the number of bar. So how do you find the number of bar? So number of bar will be the total cutting length of one bar. You multiply this by number of bar, that is 10, and this you multiply by number of footing. So that means 1.660. If I multiply this by 10 and multiply this 1, obviously it is 16.60 meter. Got it? Same thing here also it follows. That's it. Now unit weight will be 16.60 if I do, and if I multiply this by the weight of the 10 diameter bar, so it is 0.62, right? So if you want, you do it manually. So it is 0.62 or 0.617. Okay, you do it manually, you'll get 10.25. That's it, simple. Now coming to the number of bar, obviously number of bar is very simple. We'll do the number of bar also. We got 10 there, but I'll show you manually how it has to be done. Okay, yeah. Now coming to the number of bar. So how do you find the number of bar? We got 10 here. So I'm finding the shorter span bar. No, if I'm finding the shorter span bar, I need to take the longer span, which is 1400. So wait. So I'll do it. So 1400 minus 50 on the left side, minus 50 on the right side. This will be divided by the spacing of shorter span, which is 150, and plus 1. So do it. It is 1300. We'll divide it by 150. So if you have a calculator, do it. So let me do it here. Okay, I'll do it here only. Okay, plus how much it is? 1300 divided by 150. So I'm getting 8.667, which I can consider it to be 9 because it is greater than 0.5. So 8.667, I can consider it to be 9. Okay, or even I can write here comma 0. If I write comma 0, I think it should take 9, or I should round it up. Yeah, let me round it up. So ROUND, round up, and yeah, so round up. Wait. ROUND, round up, and this one. Okay, finished. Exactly. So it's coming 9. So 9 is actually number of bar. It's actually a spacing. So plus 1 we are supposed to do, no? Because you see the formula, plus 1 I have done. Okay, 9 plus 1 is 10. That is why I got 10 here. Getting my point? Very simple. So in this way, I verified everything manually. And same thing you can see in the Excel sheet. Okay. And from here onwards, I'll not teach you anything manually because anyhow for 2 problems, I've done it manually. Okay, fine. So 2 is done. Great. Next, what you're supposed to do? Very simple. Next, we are supposed to do for F3 footing. Then we have for F4, F5, F6, F7, F8, and F9. So you can do it on your own, no? Nothing. Whatever you have done, again copy. You can either copy from here or you can either copy from here. No issue. I'll copy from the first footing only. Copy this, select up to here. Okay. Say Control C. Come here and paste. Say this is the third footing. Everything is ready. Come and make this as number 3. Okay. Then come back to the drawing again. See your F3 footing. So it is 1850 by 1850 by 500. So come here and write here. It is 1850. Okay. and this is also 1850, and this is 500. Okay, great. Finish. So this is again 1850. This you have to change. So why did I did do an Excel sheet something like this? Is for the very same reason. Automatically everything will get updated. If we are not interlinked in this way, no, then we should have come and change every time here. Now since we have interlinked, it is easy for me now. So 1850 again. Done. This also got changed, and this will be 500. Right? Done. Everything. See, this time this also got changed. 266.67. Now it is not coming in this way, so I need to round up. Okay. Say round up. ROUND. Round up. Because I don't want anything in the decimal point. That is why. Okay. Round up, comma, 0, and close the bracket. And I think one bracket I need to open here. Enter. Okay. Okay, let me do that. See, how many open brackets are there? One open bracket, two open brackets. So two closing bracket will come. So number of open bracket should be equal to number of closing bracket. Okay. So one open bracket I have done here. Done here. And I'll say comma and I'll say 0 here and I'll close the bracket. Okay, it's not coming. Now it's okay. Now it's correct. See, it's coming to 67. No, earlier it was coming to 66 point something. So now it is 267. It is okay. Okay, fine. Getting my point? What I did round up here. So when you do round up and put a comma and say 0, it will take the next higher value. Got it? Yeah, because practically 266.67 is not possible on the side. Okay, fine. So that's it. So once you do this, you got the answer. We'll see what answer I got here earlier case. Yeah, see here also I got 266 point. How many bars I got? How many footings are? Yeah. Well, see, we did few mistakes. What are the mistakes? Not mistake. Go back. See the number of footings. Okay. Earlier it was 1. No, I think this should be 1 only. F1 it was 1. F2 footing 3 numbers was there. So come to the Excel sheet. Here you have to input 3. Okay. And here you have to input 3. It will come. Now you verify your answers. See, it is 3, no? 3 and 3. What is the answer you got? 27.657. And see how much we got. Okay. We'll see. We'll verify this. Okay. Yeah. So 161.660 is coming. This is correct. This 44. It is 44 point. Okay. 3 and 3, no? So 10, 3 and 3. So it is coming. Okay. 3 into 10 into this. This should be correct. And I think 3 into, yeah, this number of bar is 9 here, no? And here we got 10. Here we got plus 1 and 0. This is 10. Okay, no problem. Then not an issue. Okay, because anyhow the answer remains the same. Think round up 1300 minus divide by spacing, that is 150 plus 1 and 0 we have done. Here also it is same thing. Yeah. So this number of bars, it is coming. Okay. Where is the number of bar? Yeah, number of bar, it is 9. It is coming 10 here, no? Here it is 9. Why it's so? Because round up. Okay. Uh, okay. It is okay. See here one mistake has happened, no? Why? Because it should have been 1400. By mistake I have written 1000, because if it is 1400 then it is correct, and hit the, now it's correct. See, this should be 1000. Okay, sometimes that error happens in Excel sheets and all. Not an issue. Don't concentrate on the error. It's okay. 10 and 10. Now you see 49.800, 30.727. Yeah, 13 point. Okay, see again one thing, you should be in a position to identify the error. Error will be done by everyone, but if you are able to understand the error, that means you know the concept. Okay, that's it. Very simple. Because tomorrow it's not that every time when you work in the companies you will be doing all these things. You may have a junior who will be doing, and later he'll bring it, and you need to verify. In that case you should be knowing where that guy might have made a mistake and all. That is why both things are important. Okay, yeah, I think both the values we have matched. 30.7. Now come to the footing number 3. So in the footing number, that is this, you have to change F2 and this will be F3. Okay, This is F3. Hmm? F3. So go back to the drawing again. So F3 footing, how many are there? 4 numbers are there. So quickly input 4 here and input 4. That by default it will take. Next, what is the size of F3 footing? 1850, 1850, 500. So it is correct. 1850, 18500. Okay, good. So what is the answer you got? Cutting length. Just verify the cutting length. Yeah. So here 4, 10, 100. Okay. Spacing also you need to check now. See. Now come here. See, always whenever you do, come here, F3 footing, numbers you have to check, size. Now you see the diameter, 10 diameter, 10 diameter, but spacing is 100 and 100. Okay, so what you do now? Diameter is 10 and 10. This spacing should be 100. Make it 100. This also you make it 100. Done? Yeah. Now verify your answers. Okay, fine. So third footing, how much they have got? 4, 10, 100. So it's a 12. How much we have put? 10 diameter. What is the diameter of a bar for F3 footing? It is 10 diameter and 10 diameter. Okay. So it is 10 and 10. We have put 10 diameter, 10 diameter. And the number of bars, how much they got? Okay. They got 12 here. Hmm? Okay, okay. So there is one mistake here, no? See, everywhere it is taken. Again, this should be 1850. 1850. Now it will come correct. Now it's correct. See, again, this is 1850. Got it? Then 1919 I got. This is okay. See, sometimes when you do an Excel sheet, no, it will come something like this. See, it's coming like this. The reason is that it is not having enough space. In that case, you just drag it in this way. Your answers will be visible. Okay, fine. So 1919 we got. Here also I got 1919, 2244, 2243. So 170, 170. Here also it is 170.54, 170. Got it, no? Everything is correct. Now coming to the this thing, that is a weight. So how do you find weight? Here it will be by default 0. It's a 10 diameter bar. So what you're supposed to do, come here. So what you do, 170.544, you multiply this by unit weight of 10. So it is 0.617 and close the bracket, hit the enter button. So what is the weight I got? 105.27. How much we got here? For third footing, yeah, 105.1. See this, after decimal point, that difference will come, not an issue. Okay. If I increase the decimal, it will be all right, I feel. Okay. Similarly, here also it is same thing. Okay. Multiply by where it is 0.617. Close the bracket. Hit the enter button. Done. Got it, no? 105.274, 105.274. Earlier, I already had done it. So here also 105 and 105. Okay, great. That's it. So in this way, I've explained you for footing number 1, 2, and 3. But luckily, you people have F4, F5, F6, F7, F8, and F9. Don't do F6 footing because F6, they have written C plan because it is a combined footing. I'll teach you later because in combined footing, you'll be having a bottom reinforcement. Then you get a top reinforcement, which I'll explain you later. But you finish F1, F2, F3, F4, F5, F7, 8, and 9. Okay, you finish everything. Now for F9 footing, I'll explain here because rest all, it's very simple because the size is 1300 by 1300, 1550 by 1550, no? Fine. But whereas F9 footing, no, it is 1100. Actually, it is 1750 by 1100. Okay. Length 1750 by 1100. So I'll write it 1100. Okay, great. So for this, I'll teach you now. Again, go back to the Excel sheet. Here already I've done it. Okay. Here already I've done it. So I think there are a few mistakes in this Excel sheet. No, the reason is that here everywhere it is 1200 I've taken. So this should be changed because since I copied, no, that is why that error is coming. 2000. Done. Now it is correct. Similarly, here also that error is coming. So 2250, 2250. Here also it is 2250. See, if you understand concept once, it's very easy. Okay. So it is 1300. Rest all things are correct. Only, yeah, this is 1300. Okay. This is also 1300. Fine. This is 1550. 1550. And this also it is 1550. Yeah. Okay. Done. Next. This is last one, 1700. This will do. So always remember number of bar. If it is shorter span, you have to take longer one. So it should be 1750. And okay, it is correct. And if it is for longer span, you have to take shorter span. Shorter span is 1150. I'll explain you for this. Okay, done. Fine. Now we'll come to the last footing, that is F8 footing. Okay. So I'll teach you here only and we'll verify the answer. Yeah, last footing, what we'll do, we'll copy from here only. Same thing you copy. Okay. Up to here, say Control C, bring it here and write Control V. So this will be the last footing. What is the serial number of that? 8 numbers. I'll write 8 here. Okay. Fine. And what is the name of the footing? The footing name is F8 now. F8. Okay. And it is actually 1750. 1750 by 1100, isn't it? 1100. So we'll verify that. Yeah, it is 1750. How much it is? 1750. Yeah, by 1100, and depth is also 405. So this length you input 1750. This you input 1100. Okay, this is 400. Fine. So now we'll start with this. So F1 bar. No, this is not F1. You should write here. Okay, F8. See, there are few changes which you need to do when you copy. So it is because we are doing F8 footing. So it should be F8 footing. Okay, great. Similarly, I think here also I didn't change all these things. Here also, see, when I did F2 and all, no, it is Fn only. Make changes here. You can do it later also. Okay, first you concentrate on the procedure. So once you know how to do, later this can be changed. But when somebody comes and sees your Excel sheet, it should be correct, because your Excel sheet may go for checking also. Sometimes the client may ask, show me the way you're done. So in that case, make it correct and give it. Okay, fine. Fine. Now, last one thing we need to check, size I have put. Come to this part. That is, yeah, how many footings are there? So F9. Okay. This F. It's not F8. It's F9. Okay, no problem. Because one footing I have not done. I'll write F9 only. No issues. Write this as F9 only. Okay. No confusion. So make this as F9. F9 and make this as F9. Okay. F9. Okay. Good. So how many footings are there? Only one footing is there. And come to the diameter. So it's a 10 diameter at 150, 10 diameter at 150. So just input that. So 10 and 10 is there. You make this as 140 and make this as 140. Okay, good. This is 10 diameter, 140. Now we'll go with this thing, that is number of bar. So we are finding along the shorter span. Whenever you are finding the shorter span, you have to take the longer span. So that is why I've done round up. Your longer span is 1750 now. Okay, we'll write that. Will be 1750 minus the cover on both the side. Fairness 50 divided by spacing. Spacing is 140 plus 1 and will comma and 0. So it is 13 number of bar is required. Okay, fine. Now come to this thing. What is that? Cutting length. See, again, one problem is coming. What is that? Every time I'm dragging down, I don't know what is 173, 1360 and all. Why? Because I haven't freeze this portion. So what you do, select here, go to view, and then you go to the freeze pen and write freeze pens. Finish. Now you see I've freezed. No, now it's visible. Now you know what is okay, what happened. Okay, wait, one mistake we did. What is that? I should select this and go for freeze pens and unfreeze, and now select here freeze pens and freeze. Yeah, now it is correct. See, now it is freeze. No, now you know what is 1360. You don't have to go top every time. Yeah, okay, fine. 140, 140. Yeah. So cutting length, this is cutting length. Cutting length will be how much? Very simple. 1000 plus 200 plus 200. Okay. Now, how did you get this 200? You know, 400 minus 50 we did. And whatever answer we got, we did 2/3 of that. So that is why 200 is coming. Okay, great. So cutting length we understood, 200 plus 1000 plus 200. And now bend deduction also I have done. Minus 4 times the D. That is 2D, 2D, 4D. That is 4 into 10 I have done, because it's a 10 diameter bar. Okay, that's it. So I'm getting 1360. The cutting length in meter will be 1360 divided by 1000, which is 1.360. Now come to the total cutting length. So total cutting length will be how much? Total cutting length will be cutting length of one bar, 1.360, multiply by number of bars and multiply by number of members, right? That is 1.360 into 13 into 1. If you do it manually also, you should get this answer. If you want, I'll do it manually. Like I'll do it here. Okay. So 1.360, multiply this by how much? Multiply this by 13 and multiply this by 1 and multiply this by 1 and close the bracket. You should get the same answer. That's it. 17.680. I got 17.680. Okay, fine. Now coming to the weight of the bar. So a weight of the bar, how you find? Total cutting length, that is 17.680, multiply by unit weight of 10 diameter bar. So your 10 diameter bar we are used, so it is 0.617. If you want, you can do it here also. Okay, I'll do it here. 17.68 is the total cutting length, multiply by 0.617, enter. So it is how much? 10.91. I'll do it here also. Multiply by 0.617, close the bracket, enter. That's it. 10.91, 10.91. Got it? Finish. Similarly, come along the longer span. Again, this remains same. Diameter was 10, spacing also 140. Coming to the number of bar. So number of bar, round up, open the bracket. You are finding the along the longer span. So you have to take the shorter span length. So the shorter span length is 1100. So click on 1100. And then minus 50, minus 50, both sides the cover will be gone. Divide by spacing is actually 150 plus 1 and dash 0. If you do hit the enter button, you'll get number of bar is 9. Now come to the cutting length. So cutting length will be again 1650 plus 200 plus 200 minus the bend deduction I have done. Okay, if you do, you should get 2010. So this cutting length in meter will be 2.01, because if you divide this by 1000, you get this. So total cutting length will be very simple. 2.01 multiply by 9 multiply, because 2.01 multiply by 9 somewhere close to 18, because 9 to the 18. So it is 18.090. So you get an idea, rough idea. Coming to this one, this part, we'll just multiply this by unit weight of 10 diameter bar and close the bracket and hit the enter button. Done. So it is 11.71 kg. That's it. So if you want, I'll verify the answer here. Okay. Here somewhere we might have made mistake. I mean, not mistake. We'll verify that. Okay. Yeah. The longer span. Here there is one mistake. No, this mistake you see, which is that this is longer span. Okay. Wait. This is because this is along shorter span, then this value should change, isn't it? Because if it is along shorter span, you have to take shorter bar only. Small mistake we have done here. This should be all right, and here it should be this portion. Done. Now I think it should match. Yeah. Okay. So 1050. Okay, this is why it is 1000 here. Okay, I've taken 1150 here. It should be 1100. What is there in the Excel sheet? 1100, right? Yeah, it is 1100 here. Okay, fine. Now it is correct. So you see, you verify the answer 10.91. Yeah, so 10.91 we are getting, and here we got 11.17. Here also it is 11.610. Got it, no? So 13 and 9. Here also we got 13 and 9. So 13, 17.68, 18.0. So again 17.68 and 80. Exactly correct. You're getting my point, no? So in this way we verify this already. I had done and kept. Okay, but here I have done in front of you. Not an issue. But anyhow, you should know the procedure to do. Slight error here and there, it's okay, and that is obvious because we are doing quantity estimation. Slight error if you go here and there, not an issue. You don't have to be exactly, perfect, because again, this is again an estimation. When you do practically on the site, we take a measurement there also. Once again, we ask the site engineer whether you people followed exactly 200 there or not. Okay, now there is every chance you may have a lot of doubts now. So what will happen? See, here we have done 200, but in site, if they don't do all these things, what is going to happen? Okay, so for that, in the next lecture, I'll explain you what all things, how you need to take care of all these things. Up to here, prepare your Excel sheet. That is next about the combined footing. I'll explain you in the next lecture. This is for the combined footing. C plan is there, no? F6. This combined footing, I'll explain you in the next lecture. Up to here, whatever combined footing or whatever isolated footing I've done, everything you prepare on your own and prepare your Excel sheets. Okay, follow the same method. Rest all things are very simple. If you have any doubt, you can always get back to me on this number. Okay. So if you put +1, it's a Indian code. Okay. Plus. Okay, this is my WhatsApp number. You can do. Else you can mail me on AKSHAYKA. So in case if you are not able to follow anything, or in case if you find some difficulties, you can always mail me here or WhatsApp me here. So I'll solve your doubts over there. Okay. Yeah. So prepare your Excel sheets up to here. We'll see you back in the next lecture. So in this lecture, we'll try to see how to take out the quantities for the combined footing. Okay, that is a BBS for a combined footing. Now, one thing you need to understand in the combined footing, what will happen in the isolated footing, we used to have a bottom mesh. That is, this is bottom mesh on the longer span, and we have a on the shorter span. This was the isolated footing, isn't it? But in case of combined footing, what will happen? Same thing. You will have a bar in the longer span. You'll have a bar in the shorter span also. But this is in the bottom reinforcement. In the same way, on the top also you'll be having a bar in the longer direction, and you'll have a bar in the shorter direction. So that's the only change what you'll get in the combined footing, which you can appreciate here also. If I try to drag this particular image, so just observe here what has happened. So you can see the bar is in the bottom also. Okay, longer span and shorter span. And similarly, the top also we are providing a reinforcement. Okay, very simple. So for this, I'll teach you how the BBS has to be done. So already I have prepared and kept it. First, I'll explain you. Then we can try to prepare the same Excel sheet. Okay. Yeah. So in our drawing, we had a footing that is F6, which was a C plan they had written. C plan means it's a combined footing. They did not mention it here. And also you remember, whenever you check the drawing, no one will mention you that isolated footing, combined footing and all. The moment you see if any footing has a top reinforcement, most of the time it will be your combined footing. Okay, like this is shorter, that is bottom reinforcement, whereas only for this footing, that is F6 footing, they have given the top reinforcement. So usually the meaning is that it is a combined footing. Now another case is that it's not that all the time whenever you have a top reinforcement it will be a combined footing. No, that is not the case. There are every chance even isolated footing will have a bottom and the top reinforcement. So remember my words, there's every chance you have a isolated footing, but you will get the reinforcement even in the bottom and also on the top. Usually this happens in case of industrial structures and all, where I had given you the assignment for the plinth beam and all. No, so those are industrial structure. There, even though it is a isolated footing, you get the reinforcement in the bottom and also in the top. The reason is that the load coming on the footing is more, and it is subjected to wind pressure and all. Because of that case, what we do, we try to provide top reinforcement also. But don't be under the impression that wherever the top reinforcement will come, only that is combined footing. No, that is not the case. Okay, fine, this much is understood. Now we'll go forward. So in this, what will happen, we have written like F6 footing, and just see the size of the footing. It is I see the size is not given here. In that case, you have to come to the AutoCAD, and once you come to the AutoCAD, yeah, this is my footing. Okay, yeah, so this is my F6 footing. You can see this is F6 footing, and I've given the size here. I mean, I've taken a dimension. Outer to outer it is 3000 mm, and from here to here also it is 3000. That means the size is 3000 by 3000. Great. So that is the same thing I've written. Size is 3000 by 3000. Coming to the depth of the footing. Okay, yeah, coming to the depth of the footing, the depth is given here. The depth won't be shown here. You have to come here in the C plan. What is the depth? F6 footing, it is 500. So I'll input 500 here. So I've written 500. Where is that? Yeah, I think I didn't upload. Yeah, so this should be 500. Okay, write 500. Done. Great. So the same thing I've done here. Length is 3000, breadth is 3000, and depth is 500. So first we'll start with the bottom bar. Here I didn't write bottom bar, top bar, because it is understood it is an isolated footing. Only the bottom reinforcement will come. But here I'm writing, first I'll do the bottom bar, then I'll go with the top bar. And you see the shape of the top bar, it is something like this. Bottom bar, it is like this. Okay, I'll teach you all these things, how it has to be done. Now coming to the bottom bar, again, same shape you have to draw. Okay, nothing is changed. The method remains the same. You'll write here F6 bar along the shorter span, F6 bar along the longer span. How many footings are there? This isolated, this combined footing of F6, how many are there? So if you go back to the drawing, it is written only one. So only one number. Even in the plan, you can see this is only one number here. Only one footing we have. So I written one here. Okay. Now come to the diameter of the bar. This also you need to input. No, go back to the drawing. Come to the F6 footing. So observe this part. What it says. So it says that supposed to make use of a 10 diameter bar at 150 center to center spacing in the longer direction in the bottom. Similarly, 10 diameter at 150 center to center in the bottom in the shorter span. Even in the top reinforcement, you're supposed to provide 10 diameter at 150, 10 diameter at 150. So your calculation will be very simple now. So what you do, come here, go back to the Excel sheet, input 10 diameter at 150. Here also you input 10 diameter at 150. Now coming to the number of bar. How do you find number of bar? I want to find the number of bar in the shorter span. So what I'll do, I'll take the longer span, that is 3000 minus 50 divide by spacing of the shorter span, which is 150 plus 1. So same thing I've done it here. See, where is that? Yeah. What I've done, round up. Always remember in Excel sheet, you have to write round up 3000 minus 50 divide by spacing, that is 150 here, plus 1 comma 0. So if you do this, you'll get 21 number of bar. Okay. Now coming to the cutting length. So cutting length, what you do? See, yeah, cutting length, what you do? Cutting length will be, how do you find? Very simple, 2900 plus 267 plus 267 minus 4 times the d, because I have 190-degree bend here, another 90-degree bend here. Okay. So 2900 plus 267 plus 267 minus 4 into diameter of the bar, which was 10. Okay. So you'll get 3393 mm. So this is in mm. I'll convert this into meter divided by 1000. Got it? Now we'll find the total cutting length. So total cutting length will be cutting length of one bar, which was 3.393. I'll multiply this by number of bar, which is 21. Multiply this by number of member, that is number of F6 footing, which is only 1. So if you multiply this, and this and this, you get 71.260 meter. Now we'll find the weight of the bar. This is in running meter, no? We have to find the weight of the bar. So weight of the bar, it's a 10 diameter bar. And for 10 diameter bar, the weight is 0.617 kg per meter. So what I'll do, 71.260, I'll multiply by 0.617, which will give me 43.967 kg of a steel is required. So my shorter span is done. Now come to the longer span. Again, I've written F6 bar along the longer span, one number. Again, of course, if you see the drawing, your shorter and longer both are 10 at 150, 10 at 150. So that is why I've written again 10 at 150. How many number of bar? Obviously, this also will come 21 because your length and breadth both are same. Your spacing is also same. That is why 21 has come. Still, you have to write equal to sign, round up. Now, you want to find the bar in the longer span. See, always remember this method. Even though the dimensions are same, it's okay. You apply the logic. I want to find the number of bar in the longer span. So what I'll do, I'll take a shorter span. So shorter span is 3000. So 3000 minus 50 divide by spacing of longer span, which is actually 150 plus 1. I have to do comma and 0. If I do, it will take the next higher value, which will come 21. So cutting length will be how? It's very simple. So cutting length will be again 2900 plus 267 plus 267, which will, and minus the bend deduction, minus 4 into d. Okay. 3393. So this will be in meter. So again, this total cutting length will be again same. 3.393 multiply by 21 multiply by 1 will give me the total cutting length. Again, weight will be same because 71.260 is a cutting length of the bar of this F6 footing. And what is the weight of a 10 diameter bar? Because we are using a 10, so it comes out to be 0.617. Got it? So in this way, I have explained you for the bottom bar, and whatever we did for isolated, same thing is here. Now the question is about the top bar. How do you do the top bar? Nothing. It's very simple. If you observe the drawing here, this practical, you will get an idea. Wherever your bottom reinforcement has gone, you have to tell me few things. Wherever your bottom reinforcement longer span has gone, isn't that even in the top also the length is also same? Agree with me? Obviously, top also whatever L you are given, bottom also same thing will go, right? That means one conclusion you can draw. Whatever my bottom longer span length I got, same thing I need to write in the top. Got it? Second thing, whatever is your shorter span, whatever is your bottom shorter span length, that is L and whatever length you got, isn't that the same? Even on the top also you have done the same thing. Top also it is same thing. That means nothing will change, only the shape of the bar is changing. In bottom, when I'm giving a shape, my shape will be like this will go to the top, and when I'm giving at the top, my shape will be in this way, right? Agree with me? Same thing practically you can see also, right? That's the only changes that is the only change you're supposed to do, right? So that is why in the Excel sheet, what I've done, I've written top bar now. How do you do this? Again, you know how to do this. It's pretty simple. Okay. What I've done is I had just copied the same thing from here. I copied it here. I did Control C. Okay. And I pasted it here. Okay. I pasted it here and told it is F6 footing, and all those changes I had done. Okay. And then what I did, no, then I inserted two rows here. Here, here I inserted. Click your mouse here, keep your mouse here, and say Control and plus. So the moment you do Control and plus, two rows will be inserted, and you can merge it in this way. Select, say merge at center. Now you write here bottom reinforcement. See, all these things you should do. Okay. Bottom reinforcement. Done. If you want to change the color to differentiate, I'll give a red color. Not red. I'll give a blue color. Yeah. So bottom reinforcement will be done. Now for the top reinforcement, what you do? For the top reinforcement, you just select this. Select it in this way. Come here, give a white color. Okay. You give white color. Now this much area you can utilize. Now again, what you'll do? You can make use of this border option. Draw border. Now you draw the border like this. See one. Okay. Come here. Yeah. Draw border. 2 and 3. So this is top reinforcement, your shorter span you did, and then leave 2 3 space and come here. This is your another one. Finish. Done. You got the shape. Else you can use you make use of this insert button, illustration, shape, and this the normal method what I thought, and that also you can do. Okay. It's totally up to you to follow whichever you want. Instead of doing this shape method, follow this border method. It's easy actually. Okay. Done. So this is done. Next, what you're supposed to do, you write here, you just select this portion, merge at center, and right here it is top bar. Now it's understood. So then you can decorate it, bring it at the center, and then you take this, make it bold, and color we have given blue, and if you want, increase the font. Finish. Bottom reinforcement, or you can write top reinforcement. Okay, done. Finish. So next, what you're supposed to just copy this, whatever you have written from here. No, you say Control C and bring it somewhere here. Okay, bring it center here. Else you can do one more thing. You can even arrange this properly. Why? You just merge these two cell. This two will be one. Okay. First you do that. Merge it in this way so that this will come in the same line. You're getting my point, no? Because it should look good. That is why I'm doing all these things. Otherwise, it's not actually required. It's not actually required. Because if tomorrow somebody asks you Excel sheet, it should be in a readable format. Even he should find it good while reading. Done. So this one I've done. You can erase. If an extra comes, you say no border, it will go. And then you select and then say thick border. Okay, done. This is also not required. Come here, or even you can say erase border, and now you can erase it in this way. Okay. Okay, don't, yeah, erase. Now what you do? Now you copy this. Say Control C, bring it here and say Control V. Okay, it cannot be done. No problem. Then you write it. Then you say Control C, paste it here, Control V. Okay, and now you increase all these things. It will take some time. If you can copy, you can copy. Sometimes that will not happen, not an issue. So what is a footing name? It is actually F6 footing, not F9. Okay, so write F6, write F6 footing. Okay, this also F6. Okay, done. Now come to the number of member. It is 1, no? I'll input 1 here. So first let me do that. Select, take it to the top, middle, increase the font of that, and then do this also, so that you don't have to change every time. Okay, what is the dia of your top bar? So dia is also again 10 diameter at 150, longer direction. B2 means shorter direction in the top. Okay, 10 at 150. So what you do? 10 at 150. So dia is again 10 and spacing is again 150. Okay, done. Next, what we'll do? We'll find the number of bar. Now to find the number of bar, we have to input this, no? So what will be this portion? We are doing a shorter span for a shorter span. So plus open the bracket. Okay, so what you do first? Okay, we need to change few things. No, I didn't do that. Anyhow, we'll do it quickly. So this is actually 3000. This is also 3000. This was 500, isn't it? Yeah, this also I'll change. This was 3000. This was also 3000. And this was 500. Okay, got it? No, you also try to do along with me. Don't wait. Hmm? Yeah, now this will come. So you can round it up. Plus, we'll write round up. Okay. Why this is coming? Because again, we should round it up. Okay. This will write comma 0 and close the bracket. It's not coming, so you have to open the bracket again. Open the bracket, close the bracket, enter. Now it's okay. You got now why this is coming? Because the decimal point will come. Whenever the decimal point comes, you should say round up. Or how many open brackets you get, no, that much close bracket you should do. Sometimes see, now if I don't give this bracket, it will show error. See, this error will come. Whenever you get an error, something like this, it means that the number of open bracket and close brackets are not matching. So now you see how many open brackets are there? One, two open bracket is there. And here another three open bracket. So one close bracket, two close bracket, and three close bracket. And hit enter. Now it is all right. Okay. So if you get such problem, that means your open bracket and close bracket are not matching. Try to see. If you open three, then close three. Okay. Great. Fine. So once this is done, yeah. This answer we have verified. Now you see this is matching. No, how much we got here? 7126. This is also 74 we are getting here. Okay, I'll verify it. Okay, so that okay, this is 150. No spacing. Now it should be all right. Yeah, now it is all right. See, 71 to 74, 71 260 260. Here small changes will happen. It's okay, no issues. We'll go with this only. Yeah, 10 at 150. Now you infill this. I mean, yeah, plus open bracket. So shorter span, no? Shorter span is how much? 3000 minus 50 minus 50. Close the bracket. Okay, 2900. So bring it at the center. Bring at the center. Make it bold if you want. Change the color to the red. And this also you change it. Got it? How it has to be done? Finish. Now here you don't input again. I mean, you don't have to write again. Simply interlink it. That means plus. Just click on this. Click on this part. Okay. And hit enter. I mean, click here. Plus this portion, enter, finish. Same thing it will copy. Again here also plus, you can copy this or you can interlink this. Anything is okay. Interlink this. And then this has gone to the side. Click on this and bring on the left side. Okay. This also correct. So click both, make it red in color, make it bold and change it. Finish. Looks good, no? Now everything is correct. Now number of bar. How do you find the number of bar? So for number of bar, again, we have to do round up. Okay. Open the bracket. Then two times you have to open the bracket. So we are finding along the shorter span. If you're finding along the shorter span, I need to take the longer span. So longer span is 3000 minus 50 on the left side, minus 50 on the right side. Close the bracket, divide by spacing. What is the spacing? 150. Now it's not visible. I'll directly write 150. Okay. So this 150 when you write, again you have to write this. You have to open the bracket. Okay. And close the bracket. Finish. Then you write plus 1, comma 0, bracket close 2 times and enter. Okay, again that error is coming. The error is again for the very same reason. 3 open brackets and this close bracket is not matching. Put yeah, now it should, because why this error came? No, I gave 2 open brackets this time. So what happened? 1, 2 and 3 open brackets are there, but closing bracket you see 1, 2, 4 brackets. So again it didn't match. That is why I got this error. So in that case, what you do? You deduct one thing. Okay. That's it. Now it will be all right. See, 21 number of bar I got. Here also I got 21. Correct? No? Fine. Now find the cutting length. So cutting length, you know, plus what you do? 2900 plus exactly 267 plus 267. Then what you do? Minus, open the bracket, 4 into D. 4 into multiply by D. D is how much? 10 diameter bar. Close the bracket. How much you're getting? 3394, 3394. Again, this answer is cutting length in meter. So what you do? This answer you divide it by 1000. So you can put bracket and you can do that also. It will be correct. Okay. After that, now come to the total cutting length. So total cutting length will be how much? Cutting length in meter multiply by number of bar multiply by how much? Number of member. That's it. We'll get 71.274, 71.274. Same thing. Why? Because this and this will obviously match. Okay. Here also you see, I got the same thing. 71.260. That small variation is okay. Fine. Now come to the weight of the bar. Weight of the bar, we are using a 10 diameter. No, come here. Plus 71.26 into 10 diameter bar is 0.617 and enter. Finish. How much we got? 43. You can keep it to 2 decimal. Yeah, okay. 2 decimal, it will come 44.00. Here we got 43.96 here, which is close to 44 only. Okay, done. Finish no? So the top one you have finished. If you want, you put dash here. All these things you can put dash. 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 Now come to this portion. Again, this portion what you will do? So this was shorter. Now this is your longer one. So again, do the same thing. Longer also will be plus, open the bracket. So for the longer, what is the size you have? Longer is 3000 minus 50 minus 50. Close the bracket. Now you may ask, sir, whether we can interlink this. Instead of writing, can we interlink? You can interlink, but don't follow that method. The reason is that here length and breadth both are same. So if you interlink, nothing will change. Tomorrow you may get a footing where length is 3000 and breadth is 2500. In that case, you have to do it separately. That is why I'm teaching you separately. Okay, fine. So again, bring it the center. And now this you can interlink because this anyhow will not change. This you can interlink, not an issue. Okay, fine. Done. No? Click on both of this. I mean, click on this. Bring on the left. Make it red color. Change this font. You can make it bold also. Click on this. Make it bold and red in color. Okay, done. No, finish. Now this looks good. Now these things again you need to copy. Try to copy. Say Control C, and before that you just merge it. Otherwise, yeah, it will not look good. So these three you merge together in this way. Okay, once you merge, say merge at center, and then thick box, and yeah, box will come. Okay, now again select this, say Control C, put here Control V. Yeah, now it will come, no problem. Okay, so only the thing is shorter, you change this one to as longer span, because now I'm finding the longer span direction. Okay, I hope you're able to understand these things. Rest things anyhow you're interlink, but make sure it is correct, because since you're interlink, okay, anyhow we'll make it correctly. Longer span 1 bar, 10 diameter 150. So number of bar you change it. Number of bar, what we'll do, we are finding the longer span, so I need to take the shorter span. The shorter span is 3000 here, and hit the enter. Yeah, so 21 I got. Cutting length is same. This is correct. This is also correct. Here what will happen, this will change into 0.617 because it's a 10 diameter bar. Hit the enter. Got it? No, both are 44 and 44. Correct. And here also you see everything 43, 43.967 we got. Even if you want, you can make it as 44 also. If you decrease this, no, yeah, it will become 44 here. Not an issue. Okay. See here also we got it. No, how it has to be done. Now what you can do, you just can yeah, just select this and make this as, give one thick box. Fine here. So done, and then you can merge this thing. So select this and say merge at center. Now this will look good. So here you can give a border now to make it look good. Select that, this border you give, so it will look good. And this also you select like this and say one border. Now it looks good. Got it, no? So this is your combined footing. If you want, mention combined footing here if you want, else not required. Okay, everything is correct. Yes, fine. So bottom reinforcement is done, top reinforcement is done. Okay, great. So I hope you have enjoyed the lecture up to here. You're able to understand how the combined footing reinforcement has to be done. Okay, so try to prepare the Excel sheet. It's very simple preparing the Excel sheet. And once you interlink and all, just try to verify your answers. Okay. Yeah. Because why I'm telling is in this drawing, whatever we have there, it was easy for our calculation because 10 at 150, 10 at 150, everywhere it is 10 at 150. Now in some other drawing, you may get where your bottom reinforcement is 10 at 150, 10 at 150. Top is, let us say, 10 at 200. So in that case, what we do, we write 200 here, write 200 here. Accordingly, your answer should change. So did it change? It didn't change, isn't it? Because spacing, yeah, it didn't change because we had not interlinked. So in that case, this 150 will become 200. Okay, 200, and this will become also 200. Okay, I'll tell you how it has to be interlinked. I'll interlink because last time I didn't get chance that because it was not it was not showing. Now we'll interlink this. Okay, see. Okay, what happened? Yeah, correct. And now here also I'll interlink. Okay, so when I interlink, no, so this will change automatically. See, your answer also got changed. No, now let us say instead of 200, your spacing was 250. Now you see everything will change. 13, this also is 250. Finish, got it? So that is why you have to interlink. Now instead of 10 diameter, let us say in AutoCAD, instead of 10 diameter, it is 12 diameter. I'll change everything here. Let us say you are working on a project where you got this as 12. Instead of 10, it is 12. And this spacing, I'll go with the 225. Okay, 225, one thing. And here also it is 12 only. Usually that changes will not happen. The structure consultant will not make it so much, so much changes will not happen, but still for our calculation I'm doing. And I'll say this we are going to place it 250. Okay, usually that doesn't happen. Okay, as far as possible, the structure consultant will try to give 150, 150. Top also will keep it 150 only. Even though 225 is a requirement, we give it same so that execution point of view, it will not be a problem. That is why most of the structural drawing it will remain same, but in few places and all due to some condition we try to change. It's okay. Okay, so this is L2 is longer. Okay, and B2 is shorter span. Okay, okay, shorter it is 250, longer it is 225. What you do, shorter, no, so shorter you make it as 225, and longer it is how much? 2. Okay, shorter it is 250, no, B2 it is 250, 250, and this is 225. Okay, how did I identify? I written shorter here, so this is shorter. B2 means shorter span, and L2 is longer span, 225. So longer I've written 225. And diameter, what I've done, both are 12, 12. So what we'll do, here also 12. Okay, and here also 12. Done. Now you see everything got changed, isn't it? That is why you have to interlink in the Excel sheet. Everything will change. Simple. So if you get a problem something like this, it will change. In the same way, I'll change the dimensions also. Instead of this dimension, I mean, now I'll not change, I'll show here only. Instead of this 300 by 300, let us say you have a footing which is 4500, and this is 2500. So automatically everything also will change here. You see everything got changed, isn't it? That is why you have to interlink everything so that it is easy for you to do the calculation. Great. So I hope you have enjoyed my lecture up to here, and I've explained you everything regarding the combined footing, how the BBS has to be done. I've given you different case studies also, how it should be done. So we'll see you back in the next lecture. So I hope up to here you have finished your Excel sheets and we have understood everything. The combined footing is also covered, and also I have covered the isolated footing, and this entire drawing, whatever was given, all the BBS we have done. Okay. So once that is done, the final thing what we are supposed to do is a total quantity that is required. Now what we have done, for each footing, we have found that this much steel is required, right? 10.90, 11.16. But when you give the final details, okay, it should be something like this. You should come within a single glance, you should come to a conclusion like 8 mm how much bar is required, 10 mm how much is required, 12, 16, 20, 25, and 32. And out of that, what is the total steel that is required. So for that, what I've done, I've prepared a kind of row here. So in this way, we can identify. I'll teach you how it has to be done. It's very simple. So what you can do is, I'll do it here. Okay. Since we did up to there, I'll do it here. Or I can do it here also. Anyhow, I'll do it here only. Okay. What you do, you just select. So once you're finished up to here, just select up to this much amount. Okay. And go here, say merge at center. Okay. And then this part, what you do, you have to write all these things. Okay. So what you do, again, whatever you have written, same thing you copy, like 8, 10, 12, 16, 20, 25, 32, Control C, and you paste it here. Okay. So it will come in the same line. It should come in the same line. Once that is done, next what you're supposed to do, you drag this one. 3 you can take, or 3 or 4. It depends on you. Okay. So this will put under one column or one row and give a border to that. And next, this part also you put. Okay. Yeah, this will be for that. And this part you write up to here, this much. This will be for one, and this will be for second. You're getting my point? And then say merge at center and give a thick box. Done. Everything you're done. And here also you give a, make it bold, thick box. Okay. Now this entire thing you select, go here, keep it in this way. If you want, increase the size of that. Okay, great. Everything is done. No. Now we'll write that. That is total steel required for which one? It's a G+2 building. What we did, G+2 building, or you can write residential building. Okay. Okay, 14. And you have to write always, actually when you write the final thing, it should be in metric ton, but I'm writing both kg and metric ton. MT is metric ton. Okay. So this is how it is. Once it is written, bring it to the center, and then you increase the size of that. And if you want to change the color, change the color. Okay. And write total steel. Fine. Total steel. Got it? Done. Now 8, 10, 12, you just have to come and check here. Okay. Whether everywhere in this particular footing, luckily all the diameter what we are used, it is 10 and 10, 10 and 10, 10 and 10. Everywhere it is 10, 10, right? So everywhere it is a 10 diameter bar what we are used. That means the weight also has come in the 10 diameter column. All right. So what you do, you come here. 8 anyhow, you can make it 0. Okay. 12 also it is 0. Since there is no steel in that, everything you make it 0 except the 10 diameter. Now for the 10 diameter, what we'll do, we'll select plus sum and open the bracket, and then go on selecting from here. Okay, we'll start from here. This is 10, no? So drag it in this way. Okay, so in this way you drag it so that all the values should be selected under the 10 diameter bar. Okay, up to here. So and then close the bracket, hit the enter button. So done. So what happened this time? It's coming 966. Okay, let me check it once again. It should not come. It should come properly. Sum, open the bracket. We'll start from here. Straight you go to the top. Okay, up to here, no? And then close the bracket. Enter. Okay, it's coming 966. That means here there might be a mistake. Otherwise, we'll do one thing. Okay, no problem. We'll individually will pick it up. Okay, sum, open bracket, you are done, no? We'll start from the top. Okay, individually pick it, not an issue. Like this one plus this one. Okay, this one plus this one. Then plus this one plus this one. How much is 6 is done? 1, 2, 3, 4, 5, 6. Yeah, 6 are done. Plus 7, 8 plus this one 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 plus this one, right? Everything is selected. Close the bracket, hit the enter button. So it's coming 841.448. Then it is coming 966. No, it's coming 966 here because it has chosen everything. But anyhow, not an issue. We'll follow the same method. Okay. Sometime in Excel, changes will happen, not an issue. We'll pick it individually. Okay, yeah, plus sum. So we'll start from here now. This one plus this one plus this one plus this one. Okay, plus this one plus this one. Okay, 1 2 3 4 5 6 values are done. Yeah, 1 2 3 4 1 2 3 4 5 6. Yeah, 6 values are done. Plus this one 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 and plus this one. Done. Everything is done. Close the bracket, hit the enter. Still it's coming 966. And here it is coming 841. So we'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's coming here. And here 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is correct. And here it's coming 1, 2, 3, right? See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That means 3 are missing here, right? No problem. We'll verify that. Okay. Because again, I told you, whenever you miss anything, you should know to verify that also. I think this is missing. We have not considered this particular thing. N144, you see, N144 is missing, no? Now it is correct. Plus, again, go to the top. See, even this is also missing. N130, that is also missing. So 2 we added, and I think one more is missing. That also we need to add. Yeah, see, even this is also missing. Yeah, now it is okay. And close the bracket. N100 was not added. Now hit the enter button. Yeah, see, now it's correct. Right, got it? 966.236, 966. Again, we were successful in identifying the error. So this is how we are supposed to identify the error. Okay, great. Chalo. Yeah, done. So other than that, 12, 16, 20, we don't have, no steel is coming. Just in case here, if it was 12 diameter bar, then under the 12 diameter bar, we would have written that. I'll show you that later also. Okay, done. So once that is done, next nothing, you have to add it. Okay, here we'll write everything in kg. That is this plus this plus this plus this plus this plus this. Okay, so again, it is 966 only. So this is the total steel that is required everywhere, including all the steel. Here it is showing only 10 diameter steel, how much it is required. Here it is showing the entire steel that is required. And here what we'll do, this answer will divide by 1000 so that your answer will come in metric ton. So 0.966. So this is the actual steel that is required in metric ton. Usually when you order the steel, no, you order in metric ton, you don't order in kg. Okay, so you should say this much metric ton of steel is required. So that is why I've written metric ton. MT is metric ton. Kg, normal speaking, when I say metric ton, you don't understand the quantity. But when I say in kg, you get an idea. Okay, 966 kg. Okay, done. Similarly, here we had written total rebar quantity. I've interlinked this. What I've done, I'll do it once again. What I did is here plus I have interlinked that with this value. Okay, with this value interlink in metric ton. Enter. Finish. Okay, tomorrow if I just change this value instead of this, now I'll show you what will happen. Now let us consider, I'm giving some random values. I'm getting a 12 diameter bar. Let us say, okay, this is a final answer. You also should get the final answer, something like this. Even if it is very close to 950 also, it's okay, doesn't matter. Okay, okay, so try to do your Excel sheets and you should get 966.236. Even if you get 975, even if you get 960 also, it's okay. You don't have to be you don't have to get exactly same. If your value lies in between, if your values lie in between 950 to 1000 also, it's okay, not an issue. Okay, You don't have to worry. Maybe somewhere you might have made mistake, and it's okay, totally okay, not an issue. Because again, we add 5% wastage to this. Okay, chalo. Now let us consider in this footing, somewhere we had a 12 diameter bar where it was 230 kg steel had come, and 8 and 20 diameter we had got some 450 kg steel finished. See, automatically you see the Excel got updated, isn't it? So 966 plus 230 plus 450 will give me 1646, and 1646 divided by 1000 is 1.646 ton, and automatically you see 1.646 has come here. So that is how the interlinking should be done, so that you can do everything in a better way. Okay, fine. Okay, that's it. Now again, this is a final thing what we have got. Usually when we do this thing, uh, estimation sheet in this way, we usually add a 5% wastage to this. Okay, even though you're getting 966, you can add 5% wastage to that. Okay, either you can add, you can make a separate column, you can make a separate row here and say 5% wastage, or here itself you can add it. Okay, if you want, I'll do it here only. I'll add one more this thing, and here what I'll do, this is for the wastage. So when I say wastage, you say 5% no. So 1.05 1.05, why it is? Because 5% is, it's 1.05. If I multiply by this is my wastage. Including the wastage, this much steel you need to order, because whenever you order the steel, it's not that the same quantity will go in the execution. 5% may go in wastage. After that, that is why we try to keep those, we try to prepare the reconciliation sheets and all later. Okay, anyhow, so this is one way of doing. If you don't want to do in that way, write 0.05 multiply by this plus 0 point. If you do, okay, this is okay, you follow this, plus 1.05 into 0.05 is 5%. Okay, if you don't want to do it in that way, there's one more method which you know what you do. That's simple. You write this 966 plus open bracket 5%, no, 0.05 multiply by this value again and close the bracket. Same answer you should get. Yeah, see, 1014 only you got. You can follow both. This is easy. 1.05 into this answer will give you 5%. This value, whatever you got, it is after the 5% of wastage. Okay, that's a common practice what we do. We add 5% wastage to the steel what we have got. Okay, so I hope you have enjoyed my lecture up to here. Try to prepare the Excel sheet and try to get an answer somewhere close to this. Okay, I've given you a buffer zone from 950 to 1000. If you get, it's okay. So we'll see you back in the next lecture. So in this lecture, let me clear few of your doubts. So whatever I have taught you so far in the putting BBS, you may have few doubts like when we should consider the bend deduction, when we should not consider the bend deduction. Then in few of the cases, I told you this depth, whatever you are supposed to take, you have to take 2/3 of the depth, right? Here, if you remember, we are taken 2/3. In some of the cases, I told if it is not required, not to be taken. Now, when do you use such cases? I'll give you complete information here. See, whatever I told you right now, everything depends on the, I'll write it here. Okay. Yeah. So whatever I told you, everything depends on the type of project that you're working for. Okay. We'll make it. Yeah. So TY, type of project. Okay. That's the first thing. Second thing, it depends on the client. Second thing, it depends on the client. Okay. Client and let us say contractor. Okay. Client and contractor. So client and contractor. Hmm? So again, it depends on the way you, for which company you're working, which company you are working, and what they follow Okay. These are the three things which depends on that. Now I'll give you one by one cases. So let us say you're working in one company. Let us say this is company number one. Okay. And what they follow is they follow the bend deduction. They say we have to consider the bend deduction plus whatever this L you're taking, you have to take it completely. Okay. Second, plus L completely. I'll write L completely. Got it? So this is the first thing. So in that case, what you do, what is the reason? First is you have to consider the bend detection, and the L, whatever you're taking, you have to take it completely. So this is what that particular company follows. So if that is the case, nothing. Come to Excel sheet. Okay. Bend deduction, anyhow, I applied the bend deduction. Here you can see the bend deduction minus 4 times I have applied it. This depth, whatever you have taken, no, they are telling to take it complete depth. That means instead of multiplying this by 2/3, that means whatever answer you are getting, that is overall depth minus top cover minus bottom cover, and whatever answer we got, we used to say 2/3 of that, because that is a general construction practice what we do. Now in your company, if they say you don't have to take like that, you take complete height minus the top cover minus the bottom cover, this is what we are following, then you're supposed to follow that. In that case, you just remove this 2/3 from there. Finish. Automatically, your answer will be 300, 300, and automatically you see this also has changed. So in the Excel sheet, you see here, initially it was 8.11, the weight of the steel, and cutting length was 13.14. The moment I change that, okay, just remove that. Finish. It came to 9.22 and it came to 14.940. Got it? This is case number one. If your company is following this, or if your manager has told you that this is what we are following in a company, then you follow this. No harm in that. Okay, first thing. Now we'll go to the case number two. So again, coming to the case number two. So the case number two is, let us say, in your company, they told no need of bend deduction, no need of bend deduction. Okay, you don't have to apply the bend deduction. Okay, and also you can, whatever L you are taking, you can take 2/3 of the L. That means whatever L we got, for that again you take 2/3. 2/3 means 67%. 2/3 L. I'll write in this way. Okay, 2/3 L. Right? This is another company. Let us say this is another company where you are working, or maybe that particular company is following this particular method or this particular bar bending schedule. No problem. Then what you do? You follow the same thing. Come here. What we are supposed to do? We are supposed to not apply the bend deduction, and we can take the depth up to 2/3. So in that case, simple. Come here. So wherever you have applied the bend deduction, that is -4 into, you delete this part. Bend deduction is not required. So criteria number one is satisfied, right? Is satisfied. Finish. Second, this thing you say you apply 2/3 the depth. So 2/3. Okay. 2 by 3 if you do, it will be 200. Accordingly, you see your cutting length will be this time 13.5 and 8.33, 8.33. Previously, if it was something 9, so hardly there is any difference now. So we have taken two cases. One case where the bend deduction has to be applied, and also you don't have to take complete 2/3. Here, no bend deduction, but you have to take 2/3. Okay. In this way, there may be another company which says that, like we did previously, you don't have to apply bend deduction, and you don't have to take the complete 2/3 depth. Accordingly, you can work out. Okay, based on the companies, that is what they follow, right? So I have seen people taking, but most of the construction practice, what they do is they apply 2/3, because this L, what, for example, let us say if this is my footing. Okay, I'll explain you here. Let us say if this is my footing. Okay, let us say if this is my footing, and whatever L you are putting, right, this top will be like this. It will come in this way. I'll go with only bottom reinforcement, no need of top. Okay, this is bottom. This much it will come. Okay, only up to this much length, it is enough. Okay, because that itself is your development length. From here, if there is a column here, if this is your column, okay, so your development length starts from the outer face of the column. From here, your development length starts. Okay, okay, got it. That is a concept what we apply. Now, if the depth of the footing, is, let us say 500 mm, usually let us say if it is 600 mm. Okay, 600 mm. So if I want to find this L, if I want to find this L, so what would be the formula? Usual formula what we use to apply? We say overall depth minus, from the top will take out the 50 mm depth cover, and from bottom minus 50 mm. So it will be 500 mm. So that means this particular L, whatever you have taken, no, it will be 500. So 500 means roughly it will come up to here. Your 500 may come up to somewhere here. 500 will come somewhere here. So usually practically it's not required. 500 means if it is 600, 500 will come somewhere here, right? So practically that much length is not required, because actually it's a wastage of steel also. So that is why few of the client, what they say, you take 2/3 of the depth. Whatever answer you are getting, no, here, this answer we got, no, you take 2/3 of that. That is why I made you people to take 2/3. That means 500 is correct. For this, we apply 2/3. Okay, usually we say 67, 2/3 is 67%, right? 67% only will give the L. So if I do this, how much it will be roughly? So 500 into 0.67, 335, or 500 into, yeah, 2 divided by 3. Yeah, it will be 333 mm. Okay, so then practically what we do, we try to keep this 330. So if it is 330, then obviously, if it is 330, then obviously this much will be, this part will be up, coming up to here. So this will be 333 mm. You're getting my point? And this also will be 333 mm. Got it? So this is usually what we follow. But there are few people who say, no problem, you don't have to take 2/3, you take completely. In that case, you do according to that. Now the question is, let us say there are two people. One person is, the person one is applying this 2/3 rule. I'll write this as 2/3 rule. And there is another person who is not applying 2/3 rule. Then who is correct? Who is correct? Because when you're applying 2/3 rule, when you're applying the 2/3 rule, let us say your cutting length of the bar is coming, let us say 14 meter. I'm taking random. Okay. And when you're not applying, obviously the length will increase, it will come to 17 meter. So obviously, if it is coming 14 meter, then let us say the steel, considering the unit weight of a steel and all, let us say I'm taking some random value, it will come 100 rupees. Okay, let us consider 100 rupees or $100. Let us consider $100. Okay, I'll write $100. Okay, rough value I'm taking just to make you understand. Now here, since it is 17 meter, obviously the rate will increase. Let us say this is 150 rupees, or let us say this is $150, right? So both there is variation in the price, then whom you are going to consider? So usually this thing has to be decided initially only. Before the start of the project, you have to decide whether you are taking it or not. Okay. Now on the site, this is, everything is on the paper. I can do anything on the paper. This is Excel sheet I can do. But when you do the real execution on the site, for example, let us say on the, in the paper, in the Excel sheet you are done, you have to take 2/3 of the depth. Okay. But on the site, if these people do, completely, then what you should do in the billing, when you do the billing means this is just an estimate. When the actual work is over, for example, this work is over. Okay, let us say today you did 5 footings of similar sizes. Then you have to do the billing, no, how much cost has gone into that. When you do the billing, in that case, what we'll do, we'll see exactly what has happened on the site. Okay, that is how it is. So few people, what they do, few contractors and all, they say that we'll take complete depth. Few people, what, in order to save the money and all, what they do, they say we'll take complete height. That means this L, whatever we are putting, no, we'll take overall depth minus top cover and minus bottom cover. Let us say if your depth is 500 mm. Okay, let us say if your depth is 500 mm. So if applying that rule, 500 minus top cover 50 minus bottom cover 50, how much it will be? 400 mm. Okay. Okay, so practically this length also should be 400 mm. This L should be 400 mm on the side. Okay, but what few people do, what contractor do, they show 400 mm here, but when they do the real execution, they won't give 400. What they do, they say, what few people do, instead of that, they say 500 minus 50 minus 50 minus 50, and then they apply the 2/3. They apply the 2/3. Okay, into, you are getting my point, they apply 2/3 rule again. So how much it comes out to be? We found it to be 333 mm. So what they do, they are telling that in the paper they have shown that we'll take 400, but in real site execution they have taken only 333. That means roughly 67 mm of steel he has saved. This side 67, this side 67. I'm just speaking of one rebar. Imagine how many bars will come. Imagine how many footings will come. In that case, they can save a lot of money. So that is why whenever you're doing a billing and all, you have to go and check the site, what the contractor has done. Okay, there are people, those who show something here, they say we'll do according to this 400 only, but on the site what has happened, these people have not given 400, they have taken 2/3 and given 333. Whatever amount he has saved, that is a profit for him. Getting my point? So that is why, so BBS completely depends on the site conditions. If you are following the same thing, follow the same thing on the site. If you're not following the 2/3, if you want to take the complete depth, top cover, minus cover, do that. And same thing has to be executed on the site. You have to keep the L similar to that. If you're not doing that, then you take a 2/3 rule. Whatever answer you get, same should be the L on the site. Okay, because finally, whatever you do on the site, that itself will be paid to the contractor. Okay, all your doubts are solved. Now you don't have any problem. You can go with that. So ask your, if you're working in any companies, ask your project manager or ask your site manager like what we're supposed to do. So if your site manager says that no, we are following a 2/3 rule where the overall depth minus top cover, bottom cover, and 2/3 we do, you follow that and make sure the same has gone into the billing, because usually the billing engineer will take care of that. But you being a site engineer, you have to make sure, because ultimately the billing engineer will ask you, the site engineer, like what has been done on the site. Okay, so that is why you have to understand all this concept. So I have explained everything. 2/3 rule, not applying the 2/3 rule, and even the same thing applies for the bend deduction also. Now few people say that we don't do bend deduction, and later when they come for the billing and all, they apply the bend deduction. Okay, that is 90 degree, 90 degree minus 40 we are supposed to do. Few people don't do. If they don't do, you don't, they don't claim it in the billing. If you do, you claim it in the billing. Okay, getting my point? So that is what I wanted to tell. And I think with this class, all your doubts, whatever you have, is everything solved. So finally, whatever you follow on your site, you do that. Okay, now you may ask, sir, I'm running my own consultancy, or I don't have anyone to ask. Then what I do? So what I say is you apply the 2/3 rule, which is a right practice to be done, because that much L is actually not required. Okay, because if the footing is only 300 mm depth, it's okay. Imagine an isolated footing having a 600 mm depth. In that case, you're just giving 500 mm L. So 500 on left side, 500 on the right side is 1 meter. So roughly you're wasting a lot of steel. So the simple procedure, you apply the 2/3 rule. Bend deduction, you don't have to do that. And if you want to do, you do it simple. Apply the 2/3 rule and don't do the bend deduction. This is what I say. But if your company follows that, you follow according to the bend deduction rule and you apply the 2/3 rule. It's completely up to you. Got it? Great. So I hope you have enjoyed my lecture up to here, and I've given you a complete idea regarding this bend deduction part and all. And similarly, based on that, what has happened, based on that, I have prepared the Excel sheet and I've explained you how it has to be done. Okay, now if you want to change anything, you can change here. Ultimately answer also will change. For example, what I can change is uh, let me change only one small thing. Okay, otherwise my Excel sheet will change completely. Here I'll just take it out, this bend deduction, I'll take it out here, and here also I'll take it out, and you see what is the variation which has happened here. So small variation, and final value also variation will happen. Okay, now okay, see, you see no much variation has happened. I'll show you one second. See it now, answer is how much? 966.236. Okay, it is 966.236 is the answer what I have. And if I don't apply the bend deduction, what will happen? I'll take it out, and this also I'll take it out. Yeah, so what has changed? Nothing has changed. Nothing much has changed. Hardly anything has changed. See, initially it was 966.236. Now it has changed to 681. Hardly how much mm? 0.4. 0.4 has changed. That's it. Okay, not a big change has happened. Even if you put a cost also, nothing will change here. Getting my point? So based on the requirement, you can do that. Okay, great. I did for one, you can do it for, you can prepare same Excel sheet, you just copy the same Excel sheet. Okay, say more copy and create a same Excel sheet, and in that you don't do the bend deduction, in one you do the bend deduction. Okay, you can prepare two Excel sheets and you can compare the value. That also can be done, just in case if you want to see how much variation will happen, you can do that. Okay, great. So that's it. So I'll get it back. Yeah, fine. So we'll see you back in the next lecture. So here I'll give you a lot of assignments, and also I'll be explaining a few of the complicated footings where you can take out the BBS. The method remains the same, but still since I take a lot of assignments so that you don't find any problems in future, we'll try to take that. So all these drawings I've already given you. I hope you have downloaded that. And if you remember, we had taken the quantity estimation for this footing as an assignment. Now for the same footing, you see, this time the reinforcement is given. Okay, what is written here? Raft bar in bottom, that is reinforcement bar in bottom, 12 diameter at 155 center to center spacing, and bar in top, that is both ways. Okay, now here what has happened? See here, this is actually a kind of isolated footing. If you observe here, it's isolated footing only. Why? Because there's one column and there's one footing, so it's isolated footing. But here, like I told you, all the isolated footing will not have only the bottom reinforcement. There's every chance that may have your top reinforcement. So when this situation comes, usually when you have a industrial structures and all. That means you're putting a RCC substructure. Over that, a steel structure will come, like your column, the steel column, the purlins, the rafters and all. Due to the wind load and all, there may be uplift and all. Sometimes, because of that reason, we give the top reinforcement also. And if you don't give the top reinforcement, that column may punch your this thing, that footing, and it may bulge in this way, this portion. That is why, in order to take care of that, minimum reinforcement will be given in the top also. So that is why, if you observe here clearly, see, the bottom reinforcement is given, which we usually give in isolated footing, and then the distribution bar. But similarly, on the top also we have given. This is actually a case of a combined footing, but it is not combined footing because you have one footing and one column. But I explained the reason behind that. Okay, so that is the reason you see you get a reinforcement here. It's written in the bottom, and they write both ways. Now they see, they don't give a column. All the drawings you will not. It won't be like you think. Usually, what is mentioned here, both ways. It means shorter span and longer span. This is in bottom. Okay, this is for the bottom. Similar, this is for the top. Again, both way means top shorter and top longer. Both way means bottom shorter and bottom longer. Few people, instead of writing in this way, they would have made 4 columns. Like, this is for the shorter bottom, shorter longer. Then again for the top shorter, top longer. This they would have done. But here this person has not given. Now you can do the BBS for this. Very simple. This BBS, whatever you are going to do, it's similar to the Excel sheet what I've taught you here. This one, the combined footing I've taught you, same thing. This is how your BBS should look. So your bottom shorter will come, bottom longer will come. Then again your top shorter will come and top longer will come. Okay, nothing will change. If you want, we can do that also. I'll just input these values and you'll get the answer. Okay, so let me do that quickly. Okay, so it's written. Okay, first you have to mention the size of your footing. So it is 2900 by 2900. Just input here. I'll input here 2900. Okay, yeah, 2900 done. This is also 2900. Okay, finish. Okay, then what is the depth of your footing? So depth of the footing is 500. So input here 500. Done. Finish. So accordingly, you see, you got this reinforcement. Okay, you got the this. Okay, where did I put? Wait. It has gone to the top. No, it should come here, not there. Yeah, here it should come. This is that footing. Okay, how much it is? 2900. 2900 and 2900. Okay, and depth is 500. So depth is 500. This is done. So you got the answer here. Your cutting length 2900 minus left side 50, right side 50 will be minus 100. So 2900 minus 100 is 2800. You know that. Same by default, you got the answer. And this depth also we know, 500 minus top cover minus bottom cover into 235 do. Same thing I have done. You got it as 267. Got it? Fine. Now come to the reinforcement part. So reinforcement has written, you're supposed to make use of 12 diameter bar. How many F1 footings are there? So number it's not mentioned. Will for our understanding, I'll take only 1 year for time being. Okay. And what is the reinforcement? 12 diameter. So input 12 here. Input 12 here. Input 12 here. Okay. Fine. And it is 155, 155. So it was earlier I had put 150. You make it as 155. Okay. And here also you make it as 155. Done. Where did I do? Along the bottom I did. I want top also. This is top reinforcement. Similarly, come here. Top also you change. So once you change here, automatically this part also will change. Only the thing is you have to change this part now. Okay. This is 12 diameter. No, make it 12. This is also 12. Why? You know the reason. Okay. 12, 12. And what is the spacing in the top reinforcement? See, it's top written in both ways, shorter and longer. It is 175. So I'm making 175 here. I'm making 175 here. Finish. Done. Okay. Accordingly, you don't have to do anything. You got the answer. Total 20 bar is required. Here 20 is required. And in the top, you require 18 and 18. Why the okay? Why this becomes 17 then? This is 18. Okay, round up. I think small mistake we have done because this should have come. Plus 1 0. Plus 1 0. Then why it's not coming? 175, 12, 12, 175. So round up, round up. Okay, wait. Okay. So this is one problem. See, if you interlink, if you write 3000 and all, it will create a problem. So always try to interlink it. shorter, no? So I should take longer one. Now it should come correct. Yeah, 17. Okay. Because manually I'd input 3000, no? So obviously Excel sheet will not work out. So always try to interlink that. This, it has to be interlinked. Okay, great. Now it is 17, 17. And I think, yeah, here also there is a mistake. See, here also 3000 manually I had written. You should not write. You're finding along shorter, no? So you have to take the longer span. Spacing you're finding, no? Yeah. And here also, it should not be 3000. Okay. You're finding the shorter, longer, no? You have to take shorter. That is P. Now it will be, now it is correct. Here also, you have to take, fine. Now here it is correct. Okay. Anyhow, let me make it clear. I have taken shorter span. If I'm taking shorter, I have to take the longer one. Okay. Longer I have taken, correct. And if I'm taking the longer, I have to take the shorter. So shorter will be, yeah, shorter will be C. Yeah, so correct. B and C. So, okay, fine, good. Done. Finish. Your answer is ready. Only the thing is what change you're supposed to do, no? This answer will come in 10 diameter, which is actually wrong because we're making use of 12 diameter, no? So in that case, what you do, you strike out the answer, you delete this, you delete this, you delete this, you delete this. Why? Because it is 12 diameter, so your answer should come in 12 diameter. So what you do, you just come here, say plus this total cutting length, you multiply this total cutting length with weight of 12 diameter, which is 0.888, and hit the enter button. Finish. So 58.35 kg of steel is required. Similarly, here also you're supposed to do same thing. 65, multiply this by 0.88. Okay, fine. Similarly, here also plus, click on this and multiply by, again it's a 12 diameter, so 12 diameter is 0.888. Enter. Similarly, here also this one multiply by this one, enter. Got it? So this is the right answer what you have got. Got it? So if you want, you do it manually and check the answer what you have got. You'll get the same answer. So that is the easiness of doing a Excel sheet. If you prepare an Excel sheet in this way, you can take out all the quantities. Yeah. So one I've explained. Similarly, rest you try to do on your own, because now you are in such a position where you can do all these things. Okay. Similarly, try to do it. I always tell, if you're working for the first time, do it manually. Then do it on the Excel sheet and try to verify the answers. Only then you'll have a confidence in that. Okay. Now try to do for the other thing also. All these things you try to do on your own. Okay. One assignment is done. I'll go to one more assignment now. So one more assignment is this one. Okay. Say I won't be sharing this drawing, since these drawings are not to be shared. Okay, they're confidential drawing. Only whichever is shareable, I'm going to share. Okay, don't ask for all this drawing. Only thing is, what you do, you just take a screenshot of this. If you are interested, take a screenshot. Now here, all the footings are given. Here you just concentrate on the reinforcement details. Again, same thing. Here S1 and S2 is mentioned. S3 and S4 is mentioned. What do you mean by this? The meaning is very simple. This you consider as a shorter span. This you consider as a longer span along the bottom. Again, top reinforcement. Again, this you consider along the shorter span, and this you consider along the longer span. Okay. If not in that way, usually what you can do is you can check the cross section of the footing. See, this is a cross section what is given. Now if you observe here, see where it is mentioned. So your S1 is S1 and this is S2 they have written, and this is S3 and this is S4 they have written. Okay. So how do you understand this? So it's a cross section what they have given. So you can consider your S1 to be your distribution bar and S2 be your main bar. Similarly on the top, this S4 is your distribution bar and S3 is your main bar. Okay. Yeah. Sorry. S4 is your main bar, because see, bottom shorter span, bottom longer will come. Again, in top, shorter span, and inside that will be your the distribution bar. The main reinforcement will be at the top, but whereas in the bottom, the main reinforcement will be in the bottom. In the top, your main reinforcement will be the top. After the top, the bottom next to the top. This is top main bar. This will be below that. But in bottom, this will be main. Over that, the distribution will come. And in the top, this will be main. Below that, the distribution will come. Okay. So in the top, this will be my main reinforcement. And this will be my distribution. In bottom, this will be my main reinforcement. The dotted is a distribution. Okay. Fine. And for that, they have given it here. If you don't understand from there, they have given it here also. So how they have given, you can go through this drawing. So yeah, so this is typical. They have written like this is S1. Where is S1? This is S1. Okay, this is S2. Okay, and this is why it is dotted. The dotted indicates it's a top reinforcement, and S4 is top, S1 is bottom. Okay, you're getting my point. Okay, usually if you don't understand, whenever a drawing they mention dotted, it means it is in the top reinforcement. They mention it as, they put it in dotted line. Okay, that is a typical way of doing a structural detailing. Okay, so this is S1 and S2, and then based on that you can carry you can check this thing. Come to the footing reinforcement. Anyhow, it doesn't matter to you. You just take out the quantities if you are interested to take. Okay, so you take this as shorter span, you take this as longer span, and then you top, you take this as a shorter, you take this as a longer. Okay, very simple. And anyhow it's very simple also. See, this is 125 125, it is 150 150, right? Again it is 175 175, this is 150 150, 175 175, 150 150. Okay, 125 125, 125 125. Got it? Just in case you take a screenshot of this, try to do the BBS for this. If you have any doubt, get back to me, I'll solve your doubt. Okay, again, even though this is a isolated footing, this CF means combined footing, even though it's isolated footing, again you get a bottom reinforcement and top reinforcement, because it's an industrial structure. In industrial structure you get such kind of reinforcement. Okay, two assignments are done. Next we'll go to the third assignment. Okay, see, it's totally up to you whether you want to do it or not. If you are okay with the concepts, you don't have to do that. That's it, simple. Again here also same thing, footing schedule is given. Bottom rebar in L direction, that means along the length direction, and bottom rebar in B direction, along the breadth direction. That means this is your shorter span, this is your longer span. Okay, that is why we have prepared the Excel sheet in that way, bottom and top, and along shorter span, along longer span. Okay, got it, no? Then the drawing is given to you. Based on that you can take out the quantities. So this is a drawing given. Can you take out the quantities of here? Again here you see same thing, bottom shorter longer, and top also shorter longer, but it is given in both directions. It's understood. That means longer and shorter both are 12 die at 180 180. Okay, great. So you can do the quantity estimate, I mean BBS for this particular footing also. Try to do a one or two footing so that you get an idea. Okay, fine. Next, in the same way, I'm taking a lot of drawings. You take a screenshot of this, because all this, because these drawings are already shared with you. This drawing is shared with you. This drawing is also shared with you. This drawing I cannot share. You can take a screenshot of this. Okay, don't ask me for this drawing because those I cannot share. Even this also I won't share, but you can take a this thing, what is that, screenshot of this. You note down and you can do the calculation. Then if you want me to verify, you send me this Excel sheet and I'll verify it. Okay, yeah, bottom bar, top bar, again same thing. So bottom main, this is TRNS. This is, what is TRNS? Okay, I don't know what do you mean by TRNS, but actually it's a distribution still, main bar and distribution, main bar and distribution. Okay, it's understood. You can do for this also. Okay, then after that, yeah, I had taken one drawing where I'd explained you this thing, no, which is that slope footing. For the slope footing, if you, the slope footing also same thing, BBS won't change. Only in the estimation it will change, whereas BBS remains the same for the slope footing also. So for the slope footing, they have mentioned it here. You can do this, no? See, footing F1 and F2 is given. Forget about all these things. This is not required. In when you come to the BBS, this part is not required. Okay, only we are concerned with the steel. So it's written here, B1 at CNC, B2 at CNC. That means this is along the shorter span, this is along the longer span. In the shorter span, you're supposed to use 12 diameter at 150 center to center spacing. Along the longer span, also you're supposed to use 12 diameter at 150 center to center spacing. For F1 footing, how many numbers are there? 16. F2, there is 8 number. You're supposed to use 16 diameter at 150 in the shorter span, and you're supposed to use 16 diameter at 150 in the longer span. Pretty simple. If you want, I can do this for you. I'll go to the Excel sheet and let me take one footing. I'll take this particular footing. I'll go here. Okay, I'll do it here. Fine. Quickly tell me what is given there. Yeah. So I can do it in this way. So I'll do it in this way. Okay, I want the size of the footing, which is 2300 by 2300. So let me input that 2300. Okay, 2300. And this is also 2300. Okay, done. Then yeah, so this is done. Next I want this thing. So it's a what is the depth of the footing? Okay, so in the depth, what you're supposed to do, the depth of your footing, it will be your overall depth. Oh yeah, overall depth. This depth, you're not the overall depth. You're supposed to take this depth in case of this footing. Yeah, this you may have a doubt. Yeah, see, when you're doing this slow footing BBS, your D will be only up to this depth, okay? Because your L will go only up to here, okay? So you have to consider the D2 one, not the D1. D1 is overall depth, that is not required. Your L shape will be bent only up to here. So take D2 dimension, okay? So for the D2 dimension, we'll go back to that again. So D2 we'll find from here. So we have to take D2, which is 200 and 200, both the case. So again, it is 200 for us. So I'll take 200. So depth will be 200. Okay. I'll change according to that. So this we can round up. We can make it as, yeah. So you round it up since it is coming in this point, round up and comma 0, close the bracket. Okay. So error is because of the bracket. So give one open bracket. Now it will be okay. Fine. 67, 67. Got it? No, you know, when it comes in decimal, try to change it. Yeah. Finish. Now come to number of bar. How many F1 footing are there? There are 16 F1 footings. So come here, make 16 here number and make 16 here. Finish. Again, then diameter. You're supposed to make use of a 12 diameter at 150. Okay. So this is along the shorter I am doing. First this one, 12. Okay. And spacing is 150. All right. Spacing is 150. And see, this is shorter span. Okay. So shorter I've done 12 at 150. Next I'm doing for longer. So longer I haven't changed. So in the longer it is mentioned again 12 at 150. So here you change it to 12. Yeah. You make it 12 and this is 150. Got it? Done. Finish. Once you do all this update, finish. Your answer is ready. Your answer is ready. What is the answer? Simple. Your total cutting length will be 2200 plus 67 plus 67. Okay, I haven't done the bend deduction. If you want, you know the concept now. Bend deduction, if you want, you apply it. If you want, let me apply minus 4 into, which is that? This one, 12 I'm supposed to take. Okay, done. Here also, if you want to apply bend deduction, minus 4 into 12. Done. Okay, fine. And total cutting length will be how much? How much cutting length? 2.286 is the cutting length of one bar. Multiply by number of bar. Number of bars I'm getting 16 into 16 I have to do because there's 16 F1 footing. Okay, got it? So totally it will be how much? 3. Now one change should happen. Always remember, because I'm finding a weight of a 12 diameter bar, but my weight is coming in 10 diameter column. So this I should delete. Okay. So when you do this, this is one problem. You come in the 12 section, right? Plus this multiply by 12 value. Enter. Finish. Your answer is ready. Plus this one multiply by 12 value. Done. Finish. So this is a total steel that is required. If you're putting a F1 footing of 1200 by 1200 by 400, having 16 numbers according to this particular drawing, okay, according to this particular drawing, then your BBS will be this much. Okay, when you give it to the bar bender, you have to tell cut this 2200, cut this 67, make this 67, 67, 67, 2200, and accordingly you try to do. Okay, and if you ask what should be the, if you ask what should be my total cutting length, you should tell you should cut your 2.286 mm of a bar. Out of that, 2200 will be a straight. This will be 67. This will be 67. And then the bend deduction is going to apply. So totally it should come out to this. Getting my point? So in this way, you're supposed to do the bar bending schedule. Okay, great. I think most of the things I've taken care of. Okay. And then again, I think it's enough. Most of the things I've explained you. Again it's the same thing. If you want, again not required. This is another again I won't share this drawing. Again, this is another industrial building, because whenever you find, no, this is actually isolated footing, F1, F2, F3, F4. If it is combined, it will be CF1, CF2. It's isolated, but you are getting a bottom reinforcement shorter span, longer, top reinforcement shorter, top reinforcement longer. Done. If you want, you can do BBS for this also, so that you don't have any doubt. Now let me go to few of the industrial projects. Again, same thing. This was one of the project which I had explained you in the quantity estimation time. Right now, see, this is BBS. If you can do, very simple, we can do the BBS. Same thing. Just I'm showing you just for your understanding. Okay. Yeah. Again, same. bottom face, shorter side, longer side, 16 at 150, 16 at 150. Again, top face, shorter side and longer side. You can do the BBS, very simple. What you're supposed to do, just take that value and you have to input that in the this particular area, this particular thing. Okay, because you have a bottom, you have a top reinforcement. So this you can do, no, you can take a screenshot of this, and if you want you can solve one or two problems, so that I'm trying to touch all the drawings. This is another industrial project. Okay, because industrial projects are a little bit complicated. That's it. This is one more, I think. Yeah, this is another commercial building, a very big commercial building. I won't share this drawing. Okay, because few things I have shared, I already told you. And then don't message me for the drawing. Those drawings which are shareable I'm going to do, because all these things is not required for you. Whatever is required, I'm showing it here. Okay, you can take a screenshot of this. Yeah, you can take a screenshot of this and you can take out the quantity. Okay, again see here. Yeah, see here, f1, f2, f3, f4, this is your isolated footing. f5 is also your isolated footing. f8, f9 is also isolated footing. Okay, and here what has happened, I'll tell you. See, this much footing, f1 up to f3 footing, this is your isolated footing, where you have reinforcement in the shorter span, that is bottom reinforcement, and longer reinforcement you can do. There is no top reinforcement here. f1, f2, f3 same. Similarly, your f8 and f9, f8 and f9, this is also isolated footing, where you have a shorter reinforcement in the bottom, 12 at 100 and 12 at 100 in the longer span. These things you can do. Whereas this f4 footing you see, whereas this f4 footing and your f5 footing, this is not your, this is also isolated footing, but these people have bottom and top reinforcement. Now you see how these people have mentioned it here. F4, they have given reinforcement 20 die at 125 center to center spacing. This is bottom in the shorter span, 20 at 125 center to center bottom in the longer span. Now he has mentioned top reinforcement. So in the top, you are supposed to provide another 12 die at 150 in the top along the shorter span, and 12 at 150 in the longer span. You can do that, no? Very simple. You have an Excel sheet ready, or you do it manually, you get the answer. Similarly, F5 also same thing. 20 at 125 along the shorter in the bottom, 20 at 125 along the longer in the bottom. Now for the top, they have mentioned it here. 12 at 100 center to center spacing in the shorter span, and 12 at 100 center to center in the top. Okay, pretty simple. Done. These things also you can do. Now I'll go with another footing. This is also another industrial building. Now similar. F8, F9, F10, everything is given. Bottom shorter, bottom longer, top shorter, top longer. You can do it. And I'll go to one of the commercial building. Yeah, this is another commercial building. Okay. So I've taken care of all the buildings, commercial, industrial, house building, everything I've explained you. So this is commercial building. Here what has happened? This F1 footing, this F1 footing, F2, F3, F4, all these are your isolated footing. How did I say that this is isolated footing? Very simple. Forget about everything, come to the reinforcement part. Okay, we should always concentrate on the reinforcement part. So this is your reinforcement part. Concentrate here, enough. So what is written? Bottom and top is written, fine. So only the bottom is showing, that is 12 diameter at 150 center to center spacing. Okay, this is also 12 at 125 center to center spacing, 12 at 100 center to center spacing, 12 at 100 center to center spacing. He has written only bottom, but he has not mentioned whether it is shorter or longer. If they are not mentioned whether shorter or longer, it means both ways, shorter and longer, you have to provide 150, 12 at 150 along the shorter, along the longer. In case of F1, F2, F3 and F4. Got it? Because there is nothing mentioned in the top. Now when you come to the combined footing, CF1, CF2, CF3, 4, 5 means it's a combined footing. C for the combined, F for footing. So here you will get bottom reinforcement and top reinforcement. So in the bottom, you're supposed to provide a 16 die at 150 center to center along the shorter, along the longer. And in the top is mentioned 16 die at 150 center to center along the shorter and along the longer. Got it? In this way, CF1, CF2, CF3, CF4 and CF5 you're supposed to do. Got it? So in this way, you can take a screenshot of this. If you're interested, you take out the quantities of this. Okay, very simple. If there is bottom and top mesh, use this Excel sheet, the last one, this will solve your answer. If there is only bottom reinforcement, then use any one of the Excel from here. Your answer will be ready. And make sure, because here whenever you get the answer, still answer, make sure to change it. Suppose if it is 12 diameter, it should come in 12 column. Okay. Later, I'll explain you one more way, not now. Maybe once I finish all the lectures, I'll take you to a few of the advanced topics of the Excel where you don't have to change this. Right now, you change it, but later I'll tell you one method where you need to apply the coding, if formula, if while and all. There you don't have to change. The moment you insert 16, automatically your answer will come in 16. The moment you enter 20, your automatically answer will come in 20 dia column. 20 yeah, 20 call, I mean this particular row. Right now you will not do that. Right now you practice this method. Later, once I finish all the BBS part, when I go with the Excel calculations, I'll add one lecture where you can make use that formula, because you need to write here. Okay, if and all you need to write, we'll do that later, so that you don't have to change. So that comes under the advanced part. Right now you finish these things. Yeah. So I hope I was able to explain most of the things, and I've covered almost all the drawings here. Okay, industrial, residential, commercial, and all. So everywhere I taught you how it has to be done. The concept remains the same. Only the size of the footing will change, and only the diameter and the spacing is going to change. Rest, the method remains the same. So we'll see you back in the next lecture. So in this lecture, we will see how to find the BBS for the rough foundation. Okay. So again, a rough foundation is again very simple. You just need to understand the concept. That's it. Okay. So I think I have a drawing here, and for this particular drawing, I'll show you how the BBS has to be done. So what I'll do, I'll just select this particular drawing. Okay. And let me say Control C and Control V, and just I'll paste only the rough portion here. Okay. So this is where the BBS will come. Okay. Getting my point? So very simple. You just understand the concept. Rough foundation and combined footing both remains the same. Okay. The difference will come in the size of the footing. Okay. For the combined footing, what we used to do, we used to have a bottom mesh, and over that your distribution still used to come. Similarly, you had a top mesh, and beneath that and below that your distribution still used to come. In the rough foundation also, same thing is going to happen. Okay. There won't be any difference. Okay. Only the thing is, what will happen in combined footing, there won't be lapping. What I'm trying to tell, for example, if I'm taking this as my combined footing, okay, if this is my combined footing, let us say the size of the combined footing is, let us say, I'll take this as 5500 the length, and the breadth I'll consider to be 3000 So here we used to do the simple method, isn't it? How we used to do the cutting length, this L we are supposed to find, bar will go straight in this way, and this, you know how it has to be done, isn't it? Both the side you deduct the cover, this L, you know, this length, you can do. And since 5.5 meter is less than 12 meter, so one straight bar is enough. You don't have to do a lapping and all. But in the rough foundation, what will happen? The only problem in the rough foundation is that the size of the foundation is not small. For example, if I measure this dimension, let me measure this dimension, okay, from here to here. Okay. So what I'll do is I'll increase the size of this. Go to the properties. Okay. PR, enter. And from here, I'll increase the text size. Okay. So arrow is our text. So text height is, let me go for 150. Okay, text height. It's not visible still. I'll go with 500. Yeah. So it should be visible. Okay. Fine. Let me still do that. Give me a minute. Yeah. So it's not happening, not an issue. You see this dimension, okay? So this length I measured, and you can see how much it's coming. It's coming 34,590 If I divide it by 1000, it comes out to be 34 meter. So this length is 34 meter. Now try to understand. So this length is 34 meter, but the bar what is available is a 12-meter bar. Now what will happen beyond 12 meter? Exactly. You're supposed to do the lapping. So only in the cutting length, your lap length will increase. Other than that, nothing is going to change. This much you understood. So that is why I wanted to tell you that in the rough footing, what will happen, and rough foundation, what will happen, your lap length will be added. That's it. Okay, very simple. So how we are going to place the bar? It's very simple. You just start your bar in this way. Okay, your first bar will be placed in this way. Okay, and again next bar will be placed in this way. Only up to this distance you place it. It will be placed in this way. Finish. Only 3 bars you place here. Similarly, you place 3 bars in this way. Okay, again you place 3 bars in this way. Fine. So only this number of bar. I'm just showing 3 number. That may depends on the this particular length. You divide by the spacing, you get number of bar. Cutting length is very simple. Okay, this will be my cutting length. Okay, After that, next time when you place the bar, this bar will be starting from here. It will go like this. Okay, got an idea how the bars will be placed in the rough foundation? So now you'll find the cutting length for this magenta color line, whereas previously for the yellow line we are supposed to find. Then again your bar will go in this way. Again your bar will go in this way. Okay, I hope you're able to understand. Your bar will go in this way. Your bar will go in this way. Okay, fine. So once this is done, you start with the distribution steel again. The distribution steel again, here it will be like this. It will come like this. Okay, here it will come. Maybe you'll get some 10 or 12 bars. Similarly, you do here also. Okay, similarly you do here also. Fine. Fine. After that, next what will happen? You take it completely. Now you got an idea. In the center, it will go completely. So in the rough foundation, now here the problem is my footing is not in regular shape. It is having some offset. No, that is the reason I'm doing in this way. But I'll teach you the concept, not an issue. Okay, you understood how it has to be done. This the way you put the rough foundation, you understood. No, only bottom I did. Similarly, you'll do in the top also. Like combined fitting we used to do. No, whatever was my bottom, the same will be my top. You just have to multiply by 2. You'll get the answer. That is understood. Now, what I'll do, so what I'm going to do is, see, this length we had 35 meter, isn't it? So leave it. I'll take another box and let me do that. Okay. So let us say this is a footing what I have. This is my combined footing. Okay. I'll go in this way. And what is a dimension? So for dimension, I'll go with a different this thing. Wait. Uh, yeah. Fine. Let me draw one rectangle here and I'll do the rough footing here. Okay. And let me check the dimension. Okay. I think this should be simple. Yeah. Okay. Now you try to understand. So how much it is? It is 9,452. Okay. This will not work out. No. I'll have to take a bigger one. Let me go with a bigger raft. Okay. Imagine this is a raft footing what I have. This much big is my raft. Okay. And I'll measure this distance now. What I'm trying to do, I want it more than 12 meter. That's it. Yeah. Now it is okay. See, this is 21,887 mm. So that means it comes out to be 21 meter. Okay. Now try to understand. This is 21 meter. If you want, I'll write here. This is 21 meter. Okay. Fine. Now, first let me go with, this is the first bar, shorter span bar we are going to place first. Imagine that you are putting a bar in this direction first. Once it is done, it's very simple. Now, we'll start to find the cutting length. How we are going to put the bar here? Of course, you'll start the bar in this way. I agree with that. You'll take it straight and then you are going to place it here. This is how you put. But the problem is this is 21 meter. The bar that is available in the market is 12 meter. So what you have to do? Exactly, you have to do the lapping. So how many times lapping will come? That is important. So what we'll do? We'll take 21 and we'll divide it by 12. So what is the answer you're getting? You should get some 1 point. 21 divided by 12. You'll get 1.75. So forget about the decimal point. After this 75 you forget only one, only this number I need to count. Okay, whenever you find the number of lapping, I always told you forget the digit after the decimal point, only the before that is only one. No, so only one lapping will come. So what we will do, we'll bring our bar in this way. Okay, and maybe it will stop somewhere here. Okay, and then I'll bring one more bar. I'll come here, this lapping will be done. I'll lap it in this way. I'll take my bar in this way and then L will be given. That's it. So this is how the lapping, this is how the BBS for the footing will be done, for the rough foundation will be done. Now, can you find the cutting length of this? I'll find it for you. It's very simple. 21 meter, I'll write 21,000. Okay. Minus, from the left side, I'll take, since it's a rough foundation, it will be 50 mm cover on both the side. Minus 50 from the left side, minus 50 from the right side. Okay. Fine. So what is the answer you're going to get? So 21,000 minus 50 minus 50. So this will be 20,900. Okay. So this will be 20,900. This complete length from here to here. This one from here to here. This will be how much? 20,900. But since there is one lap, we have done one lap. No, you just add the lap length. This lap length you are supposed to add. So what you will do? 20,900 plus lap length, how much you'll take? Let us say in the drawing it is mentioned 50 times the diameter of the bar. So I'll take 50, and let us consider I'm using a 16 diameter bar. So multiply this by 16. Tell me what is the answer you are going to get? Plus 50 into 16. Fine. So 21,700 mm. Fine. But this is only the straight portion. What about the L portion? This L portion, to identify the L portion, you should know what is the depth of your foundation. For raft, let us consider the depth of my raft foundation is 1,500 mm. The raft and all won't be like 400 mm, 500 mm. It will be at least more than 750, 1,000, 1,500 mm. I'll consider the depth of my raft foundation is 1,500. So can you find the L? It's very simple. 1,500 minus top 50 mm cover minus bottom 50 mm cover. And now, if you want to multiply this by 2/3, you can do that. Else, usually for the raft, this L will be very big. This L will be usually big. So what we'll do, we'll go with the same answer. Or what we can do is, we'll take 2/3 of this. This is a usual construction practice what we do. We don't keep the complete L. But again, it depends how it is given in your drawing. But here for our understanding, I'll take 2 by 3rd. Okay. Which we usually did for the isolated footing and all. So there is no, difficulties in that. Into 0.67 I'll do. So 938 mm. Fine. Finish. You got this L. So if you want, I'll write. This is 938 mm. 938 mm. This L, okay. And this is also 938 mm. Both the side it will be same since I'm taking 2/3 of that. Now you find the cutting length. Now it's very simple to find the cutting length. So the cutting length will be how much now? So add everything. 21,700. This is span plus 938 on the left side plus 938 on the right side. So this will be a total cutting length. Okay. 21,700 plus 938 plus 938. 21,700 plus 938 plus 938. This is 23,576. Finish. Your BBS is ready. BBS in the sense your cutting length is ready. So once you know the cutting length, you can find the number of bar. How you will find the number of bar? To find the number of bar, you should know the opposite length. This length you should know from here to here. I'll consider this length to be, let us say, 7,500. I'm considering a figure because usually in the raft foundation, this is what happens. 7,500, let us consider. So what we'll do to find the number of bar, 7,500 minus 50 minus 50 will do. On both the side cover you're supposed to take out. So it will be 7,400. And let us consider using a 16 diameter bar. Okay. And at, let us say you're placing it as 150 center to center spacing, or 150 will be too much. We'll keep at 200. 200 center to center. So what you'll do? 7,400 divide by 200. You're getting my point, no? It's very simple. We're not doing anything which has not been taught to you. Everything is taught to you. Only the thing is, cut in BBS of the footing of the raft foundation, only the lap length is the additional thing which you need to understand. Okay, fine. So 7,400 divide by 200 if I do, I'll get 37 number of bar. 37, since it's a number of bar plus 1, it will be 38 number of bar. Finish. 38 numbers. That's it. Your BBS is ready. You know all the thing. You know the total cutting length. You know the number of bar. You know the weight of a 16 diameter bar. Multiply all the three quantities. You'll get the weight of the steel. Simple. Very good. So this is how the BBS for the raft foundation has to be done. Okay. I hope that you're able to understand the concept. Okay. Fine. So now let us consider. I'll delete other things. Now let us consider. Okay. Yeah. Now let me consider this portion is done. No. Now, this is, I told that this is just 7,500. So if it is 7,500, there is no point in lapping because it is less than 12 meters. You just place a bar in this way, take your bar. This will be a shorter side span. I mean, shorter side bar. Okay, here there won't be any lapping. Now for us, now let us consider just in case this particular length. Okay. Now let us consider this particular length what you had. It is, let us say 15 meter. I'll write 15 meter. So in that case, you're supposed to do the lapping. So again, what you'll do, you'll bring a bar like this. You'll take it up to here. So maybe your 12-meter bar will end up to here. Then you'll bring another bar. Okay. You'll bring another bar like this. You'll lap it. You'll bring another bar. You'll lap it like this and you'll take it like this. You'll take it like this and it will be bent in this way. So how you'll find the cutting length? Again, cutting length is simple. Just 15 meter minus 50 minus 50 you do. You'll get the cutting length, the straight portion, plus whatever lap you have. It is 50 times the diameter of the bar. we have considered. So this lap length, you just add it. That's it. Finish. So again, you know this. So again, this L you have to calculate. So L, it remains the same because 1500 is for overall depth. Okay, it will be again 938, 938, and then add everything, you'll get the cutting length. And then if you want to find the number of bar, so this is 21 meter, no? So 21 minus 50 you do, you'll get how much? 20,900. How much you'll get? 21 meter. So 21 meter, 21,000 minus 50. You'll get 20,900. Okay, we'll do that only. 20,900. We'll divide it by the spacing. Let us consider spacing is again 200 mm. You divide it by 200. So you'll get 104.5. So you'll take 105 plus 1. So 106 number of bar is required in this direction. So you'll be providing 106 number of bar in this direction. And then you know it's, let us say it's a 16 diameter bar only. Multiply by the unit weight of that, you'll find the BBS. Got it, no? So this is the only thing, only the difference which will come in the rough foundation. Rest all things are very simple. Only the thing is lab portion you need to understand. But again, there's one more catch in this. What is the catch? I'll tell you. Okay. So the catch is, let me remove this thing. Remove this thing. These things are not required. Okay. I'll take out this portion also. And I'll take out this portion. And I think, yeah, this portion also I'll take out, not required. Now, every time, now whatever we understood is from the quantity estimation or from the BBS point of view. But practically on the site, you'll not do like this. Now, you know that every time a lap is coming. So again, the next bar which you are going to provide, you'll not place it like this again. You'll bring the L-shaped bar. You'll bring it here. Okay. Then again, you'll give a lap. Then you give this thing. And you won't take it like this. Why? You know, we know one thing. Whenever you do the execution, we need to understand not more than 50% of the bar has to be lapped at one section. What do you mean by that? If I have 10 bar and in all the 10 bar, the lapping is coming. Here, how many bars you had? How much bar we got? I think 35 bar something we got. So out of 35 bar, not more than 50% means out of, let us say 36 number of bar you're supposed to provide. Okay. So what is half of 36? 18. So not more than 18 number of bar has to be lapped at the same position. So if you lap all the bar in the same position, that means this particular point will be a weak point. Got it? You're getting my point? So the code says that not more than 50% of the bar has to be lapped at one particular section. So what we'll do, the next bar will not put like this. Next bar, what I'll do, I'll change it. Change in the sense, I'll start to put the bar from here. And I'll take a straight 12 meter bar, which may end somewhere here. Fine. The moment the 12 meter bar ends here, I'll bring one more bar. Then I'll do the lapping. There won't be any change in the lapping. But now you see, did the lapping happen here? First lapping happened here, no? But the second lapping happened here. So in this way, alternatively, I'm going to do out of 36 bar, 18 bar I'll lap at this position. So next bar again, what will happen? This is my next bar, okay? I'll stop it here. Then from here, the lapping will happen. So again, you see, 50%, no? Finish. After that, next bar again, I'll bring from here. I'll take it up to here. I'll lap it here. Fine. Now you are able to understand the concept. After that, next bar again, I'll take it up to here. I'll give a lap. I'll bring it like this. Finish. I'll take up to here. After that, next bar again, I'll bring from here. I'll take up to here. Then I'll give a lap. Okay, now you tell me whether 100% of the lapping has been done. No. Why? If how many bars are there? 1, 2, 3, 4, 5, 6 bars. Out of 6 bar, what is 50% of 6 bar? 3 bar, no? So only 3 bar I have done the lapping here. Only 3 bar lapping. See, one lapping at this junction, second lapping at this junction, third lapping at this junction. So out of 6 bar, only 50% of the bar has been lapped here. Remaining 50% I have lapped at this junction, and this junction. You're getting my point? No, this should be equal. I mean, if this, it should not come parallel. All 6 bars should not be lapped here. Alternatively, this will lap here, next bar lap here. After that, here in this way. So that is what you need to understand. But cutting length remains the same. This point is from execution point of view. In the execution, when you find the cutting length, what you need to do? You need to chain the bar. That's it. Whatever bar this cutting you kept, no, this you have to turn and start from here. Getting my point? This bar, if you want, I'll take out everything. I think I should take out everything. Yeah. So in the site, what you'll do, this bar first you'll put like this one straight bar. And this lapping you'll do and putting it here. Next bar, this straight bar, you'll start from here. In this direction you'll put. So it will stop here, and this bar you'll bring in this way and you'll put it here. Getting my point? No, that you need to do on the side. Simple. Okay. Yeah. So I hope you were able to understand the concept about the rough foundation. So there is no much complications in the rough foundation BBS. Only the thing is about the lapping portion you need to understand, and only lapping portion you need to understand. While doing the execution, you need to understand about the alternate lapping. One lapping if you do here, second should come somewhere there, which where when you do the execution, the site engineer will should take care of that. As a quantity estimator, you just have to find the cutting line, which is same for all the bar. Okay, simple, no? Yeah. So I think I've explained you this concept of the rough foundation. In spite of this, if you still have any doubt, you're not able to understand, you can always get back to me. Okay. Yeah, that's it. So other than that, there is no doubt left out in this. I've explained you how the BBS for the raft has to be done. Concept remains the same. Only the thing is additional lap length you have to add. Now let me give you one more case. The case is that let us consider I have one more footing. This is one more footing. Okay. And let us say if this is, let us say 50 meter. 50 meter. So now what will happen? Again, same bar will go same only. But how many lapping will come? Because 50 meter is a span of your footing and one bar is 12 meters. So how many lap will come? So number of lap will be, that is important. Number of lap. So that will be 50 divided by 12. Okay. Tell me how much will come. So 50 divided by 12, 4.1. So 4.16, which we consider it to be 4 number. We have to just take the number before the decimal point. So 4 is the first number. So 4 numbers, finish. So 4 times you'll do the lapping. So practically what you'll do, simple. You'll start your bar from here. This is your first bar coming. First bar coming. It will stop somewhere here. Then you'll bring your next bar. Bring your next bar. You'll lap it here. It will take here. Somewhere here. Then again your 12-meter bar will end here. We'll lap here. Bring here. So 2 lapping are done. Next again your bar will end here. It'll come here. You'll fine. Next year another lapping will come. This will be a last lapping. And then it will go straight. Understood? How much lapping was there? 4. So practically how much lapping you are given? 4 only you are given, no? So 1 lap, 2 lap, 3 lap, 4 lap. Can you find the cutting length of this? Very simple. How you will find? This is 50 meter. Okay. 50 meter is 50,000. Minus 50 from the left side, minus 50 from the right side. Okay. You do that. So how much you'll get? It should be 49,900 something, no? Yeah. 50,000 divided by 50 minus 50 minus 50. So it is 49,900. Okay. Fine. Now 4 times lap you're supposed to add. So 49,900 straight portion. Okay. Plus how many lap? 4 times. So 4 into 50. Let us say each lap is 50 times the diameter of the bar. 50 into, let us say I'm using a 16 diameter bar. Okay. Plus this L I want, no? This L I want. This L I know. I'm taking some random value. Let us consider the L what I got is 750. I'm taking random, okay? Just for our understanding. Else you know how it has to be done. Whatever is the depth of your footing, top cover minus cover, and multiply that by 2/3, you'll get that L portion. So this is 750. This is also 750. Okay, fine. That you add in the calculation. So plus 750 plus 750. Yeah. What will be the answer? 49,900 plus 4 into 50 into 16 plus 750 plus 750. So this will be 54,600 mm, or let us say 54.6 meter is my cutting length. So if somebody asks you, tell me the cutting length of this, finish. Your cutting length is ready. 54.6 meter is my 54.6 meter it is. Okay, is my cutting length. After that, rest things you know how it has to be done. To find the number of bar, this length divide by spacing. If you do, you get number of bar. Number of bar multiply by cutting length into number of into weight of 16 diameter bar will give you the total weight. Fine. Yeah. Now you tell me one thing. Next bar, how you'll place? Exactly. Next bar, when you place, you have to be careful on the side. So next bar, what we'll do? We'll start from here. So this may come somewhere here. Okay, fine. Then I'll give one lapping here. I'll take the bar. I'll stop here. My second lapping will be here. Then again, I'll bring a bar. We'll give a lap here. Okay, it will stop somewhere here. Okay, then I'll bring one more bar. I'll give a lap here and it will go straight like this. Okay, only three happened. Okay, wait. This I have to be careful. This is okay. Next, I'll bring here. Yeah, I'll bring here. Next bar lapping, I'll give here. Come here. Next, it will be here. Yeah, and next it will be, yeah, now it is all right. Yeah, yeah. So how many lapping happened? Again, four lapping I should get, but it has to be alternate. Exactly. One is here, second is here, third is here, fourth is here. So alternately it has happened. So again, next when you come, the same will come here. Getting my point? That's it. So I hope you enjoyed this lecture. We're able to understand how the raft BBS has to be done. Remaining the method, the way how it has to be put, everything remains the format and all. Now by this time you should have that knowledge how the format will be done. You'll be writing same thing like here we did for the combined footing. No, like you'll be having the bottom reinforcement, you'll be having the top reinforcement. Rest everything remains the same, but it will take some time for you to make the calculation for the raft portion. Okay, yeah. So I hope you have enjoyed my lecture up to here. We'll see you back in the next lecture. Thank you.